Liar Paradox. You're alone in a silent room. No distractions, no noise. Just a single sentence written on a piece of paper in front of you. The moment you read it, your mind tightens, because it isn't just a statement. It's a challenge to reality itself. The words stare back at you like they're waiting for judgment. And whatever you decide, true or false, will pull the floor out from under logic. Only now do you learn its name, the Liar Paradox. At first glance, it looks harmless, almost childish. A sentence that says, "This statement is false," but the moment you try to pin it down, something breaks. If the sentence is telling the truth, then it must be false, just like it claims. But if it's false, then it isn't false, meaning it's true. You're stuck in a loop with no exit. Truth becomes a hall of mirrors. Let's walk through the two doors your mind tries to take. In the first scenario, you assume the statement is true. The words declare, "This statement is false," and you accept that at face value. But now, truth demands falsity. The moment you believe it, you've disproven it. The statement collapses under its own honesty. So you take the other path. Maybe the statement is false. If it is, then what it says is incorrect. It says it's false, but that must be wrong, which means it's actually true. Falsity gives birth to truth, and truth gives birth to contradiction. No matter how you twist it, the sentence refuses to sit still. It isn't like a riddle you can break apart with cleverness. It's a trapdoor built into language itself. At its heart, this is a paradox of self-reference, much like the Barber Paradox, where a man shaves everyone who doesn't shave themselves. If he shaves himself, he violates his own rule. If he doesn't, he still violates it. The liar works the same way, except it hides inside a single sentence. It's language using itself as a weapon. But the real damage isn't in the sentence. It's in what it implies about truth. We build laws, beliefs, and systems on the assumption that statements can be classified, true or false, right or wrong. Yet here is a sentence that refuses to belong to either camp. It's not nonsense. It's not meaningless. It's perfectly understandable. And still, it breaks the machinery of logic the moment you try to evaluate it. Think about this in human terms. When someone swears they're lying, how do you respond? When institutions contradict themselves with perfect confidence, how do you verify anything? When truth can reference itself, it creates cracks in the structure meant to hold it. The liar paradox whispers something unsettling. Maybe language was never designed to hold perfect truth. Maybe logic has blind spots it can't see from the inside. Maybe the very act of declaring something with certainty is more fragile than we admit. And so you sit with that sentence, unable to destroy it, unable to solve it. You can walk away from it, sure, but you can't unask the question it raises. Because the paradox was never really about the words on the paper. It was about the quiet realization that some statements don't break the rules. They reveal that the rules were incomplete all along. Yablo's Paradox. You find yourself alone in a dimly lit library. The air is thick with the scent of old paper and dust. Endless rows of books stretch above you, shadows pooling between the shelves. Your mind drifts to the statements scattered across these pages, each one a whisper of truth, a claim about the next. At this moment, your curiosity is pulled taut. You sense a trap, but it is invisible, intangible, and yet profoundly unsettling. This is Yablo's paradox. Unlike the classic liar paradox, it does not rely on a single self-contradictory statement. Instead, it forms a chain, an infinite sequence of assertions, each one declaring, all statements following this one are false. On the surface, it seems harmless, merely a string of words. But as you look closer, you realize you are stepping into a logical labyrinth with no clear exit. Consider the first statement. If it is true, then every statement after it must be false. But if the second statement is false, that would mean not all the statements after it are false, so some could be true. Perhaps the third, the fourth, or even the 10th. But then, if any of those later statements are true, the first statement cannot hold. And yet, if the first statement is false, it implies at least one of the later statements is true. And the pattern continues endlessly, slipping further into itself. There is no final statement to anchor the sequence, no ultimate end to verify truth against. Each statement references an infinite horizon of future assertions. Every choice you make, truth, falsehood, fractures immediately under the weight of the next. The paradox is not a trap sprung by one sentence. It is a trap that stretches infinitely, an invisible spiral that loops forever, always out of reach. Yablo's paradox is a self-referential paradox without direct self-reference. Unlike the liar paradox, where a sentence refers to itself, here the reference is deferred into the future. It teases your intuition. How can a statement be about something that does not yet exist? And yet logically it matters. Philosophers have compared it to standing in an endless hall of mirrors. Every reflection depends on the next, and yet no single mirror reflects the whole. So what does this mean beyond logic games? It forces you to confront the limits of truth and predictability. Systems built on sequential rules, mathematics, computer code, laws, can stumble when confronted with the infinite. Yablo's paradox whispers to our understanding of causality, knowledge, and trust. How can you ever be certain of an assertion if its truth depends on an unending future? And perhaps more hauntingly, how often do we make decisions in life, assuming that sequences of events have a final, knowable outcome? In real life, the paradox mirrors the traps we set for ourselves, expecting clarity in chains of assumptions, believing we can predict every consequence, thinking we can see the end of every story. It reminds you that sometimes the tension between truth and uncertainty is not an error, but a feature of the infinite structure of reasoning itself. And so, you stand there, in the quiet shadow of those endless shelves, knowing that there is no resolution, no satisfying closure. The statements go on forever, each one hinting at the next, each one refusing to be pinned down. You are left with the eerie clarity that some paradoxes are not problems to be solved, they are mirrors for your mind. You close the book slowly, feeling the weight of infinity pressing against the edges of your understanding. Yablo's paradox leaves you not with an answer, but with a lingering question. In the endless chain of truths and lies, what can you ever truly know? Barber Paradox. You walk through a small, quiet village. Cobblestone streets, shutters half closed, the air heavy with silence. Every villager you pass looks neat, clean, freshly shaved. There is order here, too much order. At the end of the street you find him, the barber. His chair waits empty, gleaming in the dim light, and you're told a rule that makes your heart pause. The barber shaves everyone in the town who does not shave themselves, and only those who do not shave themselves. At first, it sounds simple. The barber takes care of those who don't. Those who can manage on their own do. A perfect balance. But then the question slams into you like a sudden storm. Who shaves the barber? If he shaves himself, then he is one of those who shave themselves, which means he must not shave himself, because he only shaves the ones who don't. But if he doesn't shave himself, then by the rule, the barber must shave him, because he shaves all those who don't. Each option collapses into its opposite. Every time you try to escape, the loop pulls you back in. This is the Barber Paradox, one of the most famous logical traps ever posed. At its heart, it isn't just about razors or villagers, it's about self-reference, about what happens when rules turn inward and try to govern themselves. Think about it step by step. Imagine the barber does shave himself. Instantly, he breaks the rule, because the rule says he only shaves those who do not shave themselves. So that cannot be. But imagine instead he does not shave himself. Then the rule requires that he must shave himself, because the barber is the one who shaves everyone who doesn't. Again, contradiction. It's a trap with no exit, a razor cutting logic itself into two halves that cannot meet. The Barber Paradox is a cousin of the liar paradox. The classic line, "This statement is false." Both circle endlessly because they reference themselves, a sentence judging itself, a barber bound by his own rule. Self-reference is powerful, but it's also dangerous. It can expose the hidden cracks in the way we define truth, language, even mathematics. And here's where it grows deeper. The paradox was not meant as a riddle about barbers at all. It was Bertrand Russell's way of revealing a flaw in set theory, the very foundation of modern mathematics. Imagine a set of all sets that do not contain themselves. Does that set contain itself? If it does, it shouldn't. If it doesn't, it should. Just like the barber, the neat, logical system collapses under the weight of its own rule. But outside of mathematics, the Barber Paradox is a mirror. It shows us what happens when systems of rules try to define everything, including themselves. Laws that apply to all laws. Powers that govern all power. The moment a rule must account for itself, contradiction lurks. Think of authority. Who polices the police? Who governs the governors? If justice must hold everyone accountable, who holds justice itself accountable? These are Barber-like questions, and they do not have easy answers. The paradox whispers a warning. No system can be perfectly self-contained. Every rule, every law, every truth must lean on something outside itself, or else it risks spiraling into contradiction. So you stand once more at the edge of the barber's shop. The chair is empty. The razor gleams. You ask again, who shaves the barber? The answer never comes. Only silence. Only the weight of the contradiction. Because the point was never to solve it. The point is to confront the fragility of logic, to see the cracks where certainty should be, and to realize that sometimes the sharpest blade is the one that cuts through reason itself. Epimenides Paradox. You're standing in a quiet hall lit by flickering lanterns. The air is still, but your mind isn't. Before you, a single inscription is carved into a stone wall. The message is simple, almost too simple, and yet something about it feels dangerous, like a riddle sharpened into a blade. You read it once, then again. Each time, the meaning shifts in your mind. Your pulse rises, not because you don't understand the sentence, but because you do, and it refuses to stay still. Only then do you notice who said it. A man from ancient Crete. A man whose words are poised to break logic itself. This is the Epimenides Paradox. At first glance, it sounds like a clever joke wrapped in philosophy. Epimenides, a Cretan, declared that all Cretans are liars. That's it. No philosophy lecture, no elaborate explanation, just a statement, one that collapses into itself the moment you touch it. Here's why. Start with the assumption that Epimenides is telling the truth. If his claim is true, then all Cretans lie. But he is a Cretan. So if all Cretans lie, then he must be lying too. Which means his statement isn't true. But if it isn't true, then not all Cretans are liars. Meaning at least some of them tell the truth, possibly even him. And now you're back where you began, with a statement that devours the ground beneath it. All right then, what if he's lying? If Epimenides is lying when he says all Cretans are liars, then his claim is false. So not all Cretans lie. But that doesn't guarantee that he himself isn't lying about lying. Maybe he's one of the honest ones. Or maybe the lie is that there are no honest Cretans. The moment you try to categorize the statement as true or false, you're caught in a loop with no clear exit. This isn't just a quirky ancient brain teaser. It's a trap built from self-reference, where a statement tries to fold reality and itself into a single thought. It's the same logical knot behind the famous liar paradox. This statement is false. If it's true, then it's false. If it's false, then it's true. Logic, the one tool you trust to keep the world coherent, suddenly turns on itself. Epimenides just gave it a human face, a culture, a voice, a speaker with something at stake. The danger of the paradox isn't in the sentence. It's in what it reveals about language and logic. We expect statements to exist in one of two clean categories, truth or falsehood. But this one refuses to stay pinned down. It writhes in place, exposing the limits of systems built on binaries. And the deeper you go, the more familiar it feels. Consider politics. When a corrupt official announces, "Everyone here lies," do you trust them because they admit it, or distrust them because they're part of the systems they accuse? Think about media, or groups that call their own institutions deceitful, while still asking you to believe them. There's a strange power in attacking your own credibility before others can. It makes refutation feel like agreement. And what about trust itself? If someone warns you not to trust people like them, where does that leave you? Suspended between belief and denial, with logic offering no stable footing. The Epimenides Paradox isn't meant to be solved. It's meant to be endured. Because in the end, the point is not to find which answer is right, but to see how quickly certainty collapses when a system turns inward on itself. The paradox sits there, quiet and patient, reminding you that even a single sentence can short-circuit the rules you rely on to make sense of the world. And as you read the inscription one last time, the realization settles in. Some truths don't break when they contradict themselves. They endure because they do. Barber Paradox. You're sitting at a wooden desk in a quiet room. A blank page stares back at you, the dim light of a lamp casting slow-moving shadows across its surface. Your pen hovers in the air, not because you don't know what to write, but because you've stumbled on something that feels innocent at first, almost trivial. A sentence, just a simple sentence. And yet, the moment you try to pin it down, you feel the ground shift beneath your thoughts. You think of language as a tool, precise, obedient, controllable. But tonight, something strange is happening. You start to wonder, how many words would it take to describe a number? Not write the digits, describe it in plain English. Seems harmless, right? But now, you write the phrase, the smallest positive integer not nameable in under 15 words. And in that instant, your mind stops. This is the Barber Paradox, a linguistic trap so subtle it hides in plain sight. At first glance, it sounds like a word game, but it's not just a curiosity. It's a crack in the very structure of meaning, a paradox that uses language to attack the foundations of logic itself. Let's walk through it slowly. Imagine listing all positive integers. Now imagine describing each number using ordinary English phrases. Some descriptions are long, some short. 1. 27. The square of 9. The number of days in a leap year. Each one is a way of naming a number without writing the digits. So you impose a limit. Only descriptions with fewer than 15 words. That gives you a finite set of nameable numbers under this rule. Now, by definition, there must be some smallest positive integer you haven't named yet in fewer than 15 words. That's where the paradox strikes. Because the sentence, the smallest positive integer not nameable in under 15 words, contains just 13 words. And yet it seems to successfully name the very number that's supposed to be unnamed. If that sentence names the number, then it is nameable in under 15 words. But if it is nameable, then the sentence is false. And if the sentence is false, then that number is not the smallest unnamed one, which means the sentence shouldn't be naming it at all. You're caught in a loop. A self-destructing statement cloaked as a definition. This paradox lives in the same neighborhood as the liar paradox, where a sentence like, "This statement is false," eats itself alive. But Barry's version is more insidious. It doesn't rely on truth or falsehood. It uses description as its weapon. And suddenly language feels less like a mirror of logic and more like quicksand. What makes this so unsettling is that it exposes a hidden flaw. The idea that words can neatly wrap around meaning, that a definition is always stable. But here, the act of describing something changes the thing itself. By naming the unnamed, you destroy the category you just constructed. And it doesn't stop with numbers. Think about laws, identities, classifications, even secrets. Any time we define something by exclusion, the person no one has heard of, the group beyond recognition, the problem we haven't solved yet, we risk collapsing the boundary between what exists and what is merely described. The Barber Paradox whispers a darker possibility. Maybe language isn't a container for thought. Maybe it's a maze built of mirrors. And once you see that, the implications stretch outward. How do you count what you can describe? How do you describe what your rules prevent you from naming? How do you build mathematics on a language that can sabotage itself with a single clever sentence? You don't solve this paradox. You live with it, like a hairline fracture in the glass you thought was unbreakable. Because the real problem isn't the number, it's the assumption that words always point cleanly at reality. And so the sentence remains, a quiet trap sitting on a page, waiting for someone curious enough to read it twice. The smallest positive integer not nameable in under 15 words. You named it the moment you tried to deny it. Grelling-Nelson Paradox. You're staring at a single word on a blank page. No decorations, no sentence to hold it in place. Just a shape made of letters that somehow points back at itself. It's quiet where you sit, but your mind is anything but. You watch the word the way you might watch a candle burning in an empty room, aware that something is happening beneath the surface, even if you can't see it yet. You don't speak it aloud, you just think it. And as you do, an odd tension forms. It's not the word itself that unnerves you, it's what it claims to be. Because this isn't about pronunciation or definition, it's about identity, about whether a word can describe itself. Only now do you realize what you're staring at, the realm of autological and heterological words. Words that either apply to themselves or don't. And hiding in that simple division is a paradox that refuses to sit still. They call it the Grelling-Nelson Paradox. At first, it seems harmless. Some words clearly describe themselves. Take short. The word short is, well, short. You don't have to stretch your imagination for that one. English is an English word. Polysyllabic is not polysyllabic. Noun is a noun. These feel like playful language tricks, the kind of thing you'd bring up at a dinner table just to feel clever. But then there are words that don't describe themselves. Heterological words. Long isn't long. Green isn't green. Misspelled isn't misspelled, unless someone spells it wrong on purpose. These don't apply to themselves, so they're placed in the opposite category. So far, everything seems neat. Autological words that apply to themselves, heterological words that don't. Two tidy boxes, a linguistic sorting game. Until one question appears, is the word heterological, heterological? And suddenly the ground shifts. Let's walk through it carefully, because this is where the trap tightens. Scenario 1. You say that heterological is heterological, that it does not apply to itself. But if it does not apply to itself, then it fits its own definition, which means it does apply to itself. And if it applies to itself, then it isn't heterological anymore. So the claim contradicts itself. Scenario 2. You say that heterological is not heterological, that it does apply to itself. But if it does apply to itself, then it's autological. And if it's autological, then by definition it does not belong to the category of words that don't apply to themselves, which means it doesn't apply to itself after all. Again, contradiction. You're caught in a loop with no logical escape. Each assertion instantly undoes itself. No matter where you stand, the floor collapses. It's like trying to hold a mirror up to another mirror and expecting the reflection to end somewhere. This is not just wordplay. It's a self-referential paradox, a cousin of the liar paradox. This sentence is false. Both twist back on themselves, not by accident, but by structure. The contradiction isn't a mistake, it's baked in. The system destroys itself the moment you try to classify it. And maybe that's the point. Because now the question isn't about one word. It's about systems of definition, about classification itself, about what happens when language tries to swallow its own tail. How do you build a logical framework that includes rules about things, and also includes rules about the rules themselves? Can a system fully define itself without collapsing somewhere in the feedback loop? Or is every structure eventually undone by its own reflections? You begin to see the outline of something bigger. Self-reference isn't just a linguistic trick, it's a fault line. It appears in language, in mathematics, in philosophy, in consciousness itself. Whenever something tries to describe or categorize itself from the inside, tension accumulates silently, waiting for the right question to crack it open. And maybe that's why the Grelling-Nelson Paradox matters. It reminds you that the tools you use to define the world are not outside of it. Language isn't a lens. It's part of the thing it's trying to examine. You can't escape the recursion. You can only notice where it bends. There is no solution, not a clean one. You don't fix it by choosing one category over the other, or by forcing the word into silence. The paradox isn't an error to correct, it's a boundary to acknowledge. You stare again at the blank page. The word hasn't changed, but you have. And you can't help but wonder, if a single word can destabilize itself, what else in your world only appears consistent, until you ask it to define itself? Grandfather Paradox. You're standing in a dimly lit hallway, the kind where the air feels heavy with secrets you were never meant to hold. Your hand is wrapped around the cold metal handle of a door that shouldn't exist, because on the other side is a different time, a different world, a world where your grandfather is still young, still unaware of everything that will someday depend on him. Your pulse hammers in your ears. You know why you're here. You know what you came to do. And yet, the moment you cross that threshold, reality itself begins to tremble. They call it the Grandfather Paradox, but that name comes later. Right now, it's not a theory or a thought experiment. It's a choice hanging in the air like a loaded gun. Imagine you travel back decades before your birth. You find your grandfather, before your father or mother was even conceived. The plan is simple. Prevent him from ever having children, whether by violence, sabotage, or subtle interference. If you succeed, you will erase your own existence. You will never be born. But here's the problem. If you're never born, then you could never have gone back in time to stop him, which means he would live, he would have children, and eventually you would exist and travel back to stop him. And so the loop begins, or ends, or fractures into something that shouldn't be possible. Two scenarios form immediately. In the first, you carry out your plan successfully. Your grandfather dies. His bloodline ends with him. Your parents will never exist, and you, the one standing in this hallway, dissolve from the timeline like a name scratched off paper. But the moment you vanish, so does the cause of his death. Time rewinds the contradiction. He lives again. The universe reverts to the condition where you were born. In the second scenario, you fail. Something stops you. Maybe hesitation. Maybe physics itself. Maybe time is protecting its own continuity. You leave the past unchanged, and your birth remains intact. But then, why did you ever think you could succeed? Was the failure random, or was it necessary? This paradox isn't about family or even morality. It's about causality devouring itself, a cause that erases its own effect, an effect that negates its own cause. At its core, this is a time paradox, more specifically, a causal loop contradiction. It sits alongside puzzles like the Bootstrap Paradox, where objects or information exist without origin because they're passed in circles through time. But the Grandfather Paradox hits differently, because the stakes aren't abstract, they're biological, personal. You're not tinkering with an artifact, you're dismantling the very conditions that allow you to act. Some try to escape the trap by invoking branching timelines, the multiverse solution. In that version, you don't erase yourself. You simply create a new timeline in which you never exist. while your original world remains untouched. But that's not a solution. It's a relocation. The paradox still lurks in the logic. If time allows alterations that sever your own origin, what binds continuity at all? And if every decision births a universe, does choice even mean anything? Underneath the science fiction wrapper is a deeper philosophical wound. What if time isn't a road you can walk backward on? What if it's a structure that resists contradiction the way a body rejects poison? Or worse, what if the contradiction is allowed, but only at the cost of meaning itself? If you can both exist and not exist, depending on which moment you stand in, then identity becomes fog and causality becomes optional. And when you think about it long enough, the hallway isn't about time travel at all. It's about the fragile illusion that events line up in neat order, that everything has a clear beginning and a clean consequence. The grandfather paradox tears through that story with one quiet question. Can existence undo itself from behind? You still haven't opened the door. You don't know if you're the end of your bloodline or the reason it ever began. And maybe that's the point. Some paradoxes don't break reality. They remind you it was never as solid as you thought. Bootstrap Paradox. You're alone in a dimly lit study, the kind filled with dust-heavy books and the quiet hum of old electricity. Rain taps against the window in slow rhythmic strikes. Your fingers trace the spine of a worn journal you don't remember owning. There's no title, just cracked leather and the faint scent of age. You open it. Inside, in handwriting unmistakably like your own, are pages of detailed equations, blueprints and dates, plans for a machine you haven't built yet. Your heart stutters. You flip through more pages. The diagrams are precise, instructions complete. Whoever wrote this knew what you would need before you even asked the question. And on the final page, there's a note. You'll know what to do. You don't know how the journal got here. You don't know who gave it to you. But in that moment, a single unsettling thought settles in. What if it came from you? Just not the you that exists yet. Only now does the real weight of the situation settle in. You've just stepped into what's known as the Bootstrap Paradox. This isn't just a time travel curiosity. It's a loop. Clean, closed, and disturbing. A thing exists, but its origin has been erased by its own existence. There's no beginning, no creator, no first spark. Just a cycle pretending to be a timeline. Imagine you follow the journal's plans. You build the machine. You perfect it. You wait for the right moment in your life, maybe years from now, and then you travel back and place the journal in this very room, ensuring your younger self finds it exactly as you did. The loop completes. The object exists, but not because someone invented it. It exists because it was always placed back into its own past. Now consider the alternatives. In one version, you ignore the journal. You walk away, burn it, pretend it was a prank or a coincidence. But then the machine is never built. And if the machine is never built, no version of you ever travels back to place the journal in your hands. Which means you never encountered it in the first place. But you did. You're holding it right now. So walking away creates a contradiction your memory refuses to allow. In another scenario, you build the machine, but you choose not to take the journal back in time. You break the cycle. The past you never receives the plans. But if they never receive the journal, they never build the machine. And if they never build the machine, you never have the ability to break the cycle. Reality folds in on itself like bad paper. Where then did the information originate? Who authored the first diagram? Who wrote the last page? There is no answer that doesn't dissolve on contact. This is a paradox of causal loops, time eating its own tail. Unlike the grandfather paradox, which hinges on breaking the past, the Bootstrap Paradox preserves it too perfectly. There's no contradiction in the timeline, only in the logic beneath it. The event doesn't destroy causation, it erases the beginning of it. Think of a composer who claims to have written a famous symphony. They say it came to them in a dream. Years later, they travel back in time, and give the sheet music to the younger version of the composer who first published it. The music is never truly created, it just circulates, authorless, like an echo with no original sound, or a future historian who travels back with a copy of a book considered lost to time. They give it to the original author, who publishes it word for word. The historian only knows the text because it was published. The author only publishes it because the historian brings it. The chain is seamless. The starting point is gone. Philosophically, the implications are quietly devastating. We like to believe origin is sacred. Every object must have a first cause. Every idea a moment of birth. The Bootstrap Paradox dares you to abandon that comfort. It suggests that some things may exist without genesis, without authorship, without invention, only as loops of information preserved by time itself. And beneath that is a deeper discomfort. If something can exist without a beginning, what else can? Knowledge, identity, memory, responsibility. If you didn't invent the machine, or the music, or the journal, are you its creator or just its courier? Are you responsible for what you pass between past and future, even if you never conceived it? You're left with a question that feels like a trap. If the loop is unbroken, is it an error? Or is it simply the shape of time when viewed without ego? The paradox doesn't ask you to solve it. It only asks you to sit with the silence between cause and effect, with the possibility that some answers circle back instead of forward. And maybe, just maybe, the thing in your hands was never meant to be explained, only delivered. Predestination Paradox. You're sitting alone in a dimly lit room, the kind where shadows feel heavier than silence. Outside, the world moves with its usual rhythm. Cars in the distance, a dog barking, a faint hum of electricity in the walls. But your attention is locked on the letter in your hands. It's worn at the edges, as if it has travelled farther than paper should. The handwriting looks unmistakably like your own, and yet you don't remember writing it. The message inside is simple, but impossible. On the night of your greatest regret, you will return. Do not interfere. Everything depends on it. Your mind races. You don't know what event this is referring to, or how you received a message written by your future self. All you know is that something you haven't done yet has already been done. Only now do you realize where you are, at the edge of the Predestination Paradox. This isn't just about time travel. It's about a loop where cause and effect collapse into each other. A future action causes a past event, which then becomes the reason the future action occurs at all. You don't decide, you fulfill. Imagine this. In one version of your life, something tragic happens. An accident, a betrayal, a loss you wish you could undo. Years later, with the means to travel back, you return to that moment. But instead of stopping it, you become the very reason it happens. The fall you try to prevent, you caused the distraction, the conversation you meant to change. You delivered the words that sealed it. And now the loop is complete. But what if you refuse? What if, standing in that critical moment, you go off script? That's where the paradox tightens. If you don't do what you were destined to do, then the event that motivates your future self never happens. And if it never happens, you never go back in time, which means you never interfere, which means the event never gets caused in the first place. A timeline that depends on itself can't be rewritten without tearing itself apart. So what's really happening here? This is a causal loop, a self-contained circle where origin is an illusion. There is no first cause, no moment of choice, just a loop that sustains itself by existing. It's similar to the Bootstrap Paradox, where an object or idea has no real point of creation. But the predestination version goes deeper, because it doesn't just trap information or artifacts, it traps you. And that's where the philosophy cuts in. If your future can reach into your past and lock events into place, what does that say about free will? Are decisions yours, or are you just acting out a script written by consequences you haven't reached yet? Some argue that the paradox dissolves free will entirely, that every attempt at change is simply the path destiny uses to enforce itself. But others see something different. A system where knowledge doesn't liberate you, it binds you. Think about laws, history, belief systems, family expectations, structures that seem to offer choices, but quietly funnel you toward outcomes that feel inevitable. Maybe time travel isn't required to experience predestination. Maybe you're already living it. Because here's the part no one likes to confront. In this paradox, there's no villain, no mastermind, no external force twisting the timeline. The one who sets events in motion is you, past you, future you, or an endless blend of both. And so the loop holds. You don't break it, you become it. In the end, the predestination paradox isn't asking whether time can be changed. It's asking something far more uncomfortable. If everything you will do has already been done, then what part of you was ever choosing? And as you sit there, holding a letter you haven't written yet, one question presses harder than the others. If your fate is already behind you, where does your future actually begin? Twin paradox, special relativity. You're lying beneath a sky so black it feels painted onto the universe itself. The launch pad hums beneath your feet, a giant machine waiting to fling you into the stars. Your sibling stands a few meters away, hands tucked into their jacket, eyes locked on yours. You don't speak. You both understand what's at stake, even if you don't yet understand the cost. The engines scream to life. In a moment, you're sealed inside the vessel, your breath loud in your helmet. As the countdown begins, one thought pulses in your mind. Not about distance, not about danger, but about time. Not in the way most people mean it, not as hours or days, but as something frighteningly flexible. Something that could divide two lives that once moved in perfect sync. This is the twin paradox. It sounds simple at first. One twin boards a spaceship and travels through the cosmos at near light speed. The other stays on Earth, rooted in the ordinary flow of time. When the traveler returns, something impossible has happened. They are younger than the twin who never left. Not just by minutes, potentially by decades. But how? Time isn't supposed to choose sides. It isn't supposed to bend for one person and not the other. And yet, according to Einstein's special relativity, it does. Start with the traveler. As you accelerate to a speed unimaginably close to light, time slows down. For you, every heartbeat, every breath, every thought stretches out over a longer thread than it would on Earth. Your body lives seconds, while Earth lives hours. From your perspective, everything feels normal. You eat, you sleep, you glance at the stars streaking past like silent comets. You don't feel slower. You feel continuous. Back on Earth, your twin watches months, then years, then decades pass. They age in the rhythm you once shared. But you have slipped out of that rhythm, not by choice, but by velocity itself. Here's the paradox. From your frame of reference, the traveling twins, you're the one moving normally. It looks like Earth is speeding away from you, and then rushing back as you turn around and return. If motion is relative, then shouldn't your earthbound sibling be the younger one when you reunite? Shouldn't their time have slowed instead of yours? But the situation isn't symmetrical. You left, you changed velocity, you turned around, you accelerated and decelerated. All of that breaks the illusion of equal footing. You didn't share the same path through space-time. You bent your trajectory. They didn't. So when you land and step out, your sibling has wrinkles you don't recognize. A voice you haven't heard in decades. Memories born while you were sailing through the thin fabric of time. You may have aged 5 years. They may have aged 50. It feels like a trick of perspective, a math puzzle stretched over a human life. But this is not a metaphor. This is physics. Time dilation is not philosophy, it's reality. Tested with atomic clocks and high-speed jets, even at a fraction of light speed, the effects are measurable. What happens to your ship-bound body is not fiction. It is a rearrangement of time itself. At its core, the twin paradox isn't a contradiction. It only feels like one because your intuition lives in a world of slow motion, where time seems like a straight line instead of a field that bends under speed. And yet, beneath the science, there is something deeper, something unsettling, because the paradox doesn't just ask what time is. It asks what identity is when time separates you from someone who once mirrored you perfectly. If two lives begin in sync, but diverge not by choice, not by death, but by physics itself, what does that say about the nature of experience? If a moment for you can become a lifetime for someone else, is time something you move through, or something that moves around you? The twin paradox lingers because it exposes a quiet truth. Time is not a constant river carrying everyone the same way. It is a landscape, uneven and strange, where two siblings can walk in different directions and return to find that their memories no longer rhyme. And the most haunting part is this: you don't have to travel light years to feel it. Time already moves differently for everyone. You just don't notice until the gap becomes a wound. In the end, the paradox isn't asking you to solve it. It's asking you to stand in that silence, face your twin, and wonder which of you truly stayed behind. Tachyonic Antitelephone. You're alone in a quiet observatory long after midnight, surrounded by silent machinery and cold glass. A storm is forming on the horizon, but inside, your heart is pounding louder than the thunder. On the desk in front of you sits a device that shouldn't exist, a communicator tuned not to light, not to sound, but to something faster. You've been told it can send a message back in time, not years, not days, just minutes, enough to change something, enough to break something. Your finger hovers over the switch. Your mind races through consequences you haven't dared to name. If you speak now, if this signal leaves the present and arrives in your own past, you won't just be defying time. You'll be rewriting the moment you're currently living. And only now do you realize this is not just a machine. This is the tachyonic antitelephone. It's not the kind of paradox that plays with words or clever tricks. It's one that tears at the structure of cause and effect. Tachyons, hypothetical particles that exceed the speed of light, don't just move quickly. They challenge everything Einstein warned you about. Because in one reference frame, you're sending a message forward. In another, that same message arrives before you've even considered sending it. Imagine this. You decide to call your past self 5 minutes ago with a warning. Don't activate the machine. The signal travels faster than light, slips through the cracks in relativity, and reaches the version of you who hasn't yet made the choice. That earlier you hears the warning, hesitates, and decides not to send the message at all. But if you never sent the message, how did your past self hear it? Reverse the decision. Say the past you doesn't get a warning. You press the switch in the present, the message leaves. But in another frame of reference, someone receiving it could respond immediately and create a loop where each signal cancels the reason for the other. Every outcome twists into its opposite. This isn't just a contradiction, it's causality in freefall. The logic here is a cousin to the grandfather paradox in time travel, but it's stranger. No time machine, no wormhole, no dramatic leap through history. Just communication. Information outrunning time itself. And information is more dangerous than bodies or bullets. A message, once spoken, exists in the chain of cause. If it lands before the cause exists, what does it rewrite? Physicists talk about reference frames, how one observer's future could be another's past. If tachyons exist, they don't simply travel fast. They carve shortcuts through time depending on who is watching. To one person, the call is sent. To another, it's received first. Perspective becomes power, and chronology collapses into negotiation. Step back from the science and the implications deepen. What happens to responsibility when the effect comes before the choice? What is truth when the future can edit the past in real time? Can you regret something you were prevented from deciding? Can you claim authorship of an action that was undone before you performed it? In politics, technology, even memory, there are echoes of this paradox. Warnings arriving before disasters, outcomes shaping the decisions that supposedly caused them. We pretend timelines are linear, but feedback seeps through every system built on prediction. The tachyonic antitelephone just makes that leak impossible to ignore. You stare at the device again. You could warn yourself of failure, or send proof that you succeed, or whisper something you'll never admit out loud. But the moment you do, the moment that message leaves your present, you dissolve the ground beneath your own decision. Perhaps that's the real paradox. Not that messages can go backward, but that your identity might not survive the correction. You haven't pressed the switch yet, or maybe you already did, or maybe you never will. Either way, somewhere in the storm outside, the signal is already on its way. Schrödinger's cat. You're standing in a dimly lit room. The air feels still, almost staged. In front of you sits a sealed metal box resting on a simple wooden table. No windows, no openings, no sound from within. You don't know what's inside, or rather, you're told something is inside, but you're not allowed to check. Your mind starts to wander. You picture movement, or maybe silence, life, or the absence of it. And for a moment, the uncertainty becomes louder than the room itself. Only then are you told whose box this is, and why it exists. This is Schrödinger's cat. Not a riddle, not a meme, but a thought experiment meant to expose something unsettling at the heart of quantum theory. Erwin Schrödinger didn't design it as a trick. He designed it as a protest, a challenge, a way of asking, what do we really believe happens when we're not looking? Inside the box, the setup is disturbingly simple. A live cat, a vial of poison, a tiny radioactive atom, with a device that breaks the vial if the atom decays. In an hour, there's a 50% chance the decay happens, which means a 50% chance the cat dies. But until you open the box, until you observe the system, you're forced into a bizarre position. The cat is both alive and dead at the same time. That's the core of the paradox. Quantum mechanics says that particles can exist in a superposition, multiple states at once, until they are observed. That works fine when you're talking about electrons or photons or energy levels in an atom. But now, that same logic has been scaled up to something living, something familiar, something that can suffer, and that's where the cracks start to show. Let's break it apart. In one scenario, you accept the rules of quantum theory as they're often described. The atom hasn't been observed, so it's both decayed and not decayed. The trigger has both gone off and not gone off. The poison has both been released and not released. The cat, by extension, is both dead and alive. You're forced to believe in a layered liminal state that defies everyday logic. Reality is not one thing. It is an unresolved equation waiting for your eyes. But now take the other path. You reject that interpretation. You say the cat has to be in one definite state, whether or not you're watching. The atom either decayed or it didn't. The superposition is not real, it's just a mathematical trick. Observation doesn't create truth, it only reveals it. But then, why does quantum theory rely so heavily on observation? Why does the act of measurement seem to change outcomes? Why does the math treat possibilities as real until someone interrupts them? Either you accept that a cat can be both alive and dead, or you accept that quantum physics is incomplete, or worse, misunderstood. So what's really being cornered here? Not the cat, you. This is a paradox of measurement, of interpretation, of reality itself. It exposes the tension between quantum behavior and classical intuition. It's related to self-reference, in a way, the observer and the observed collapsing into the same moment of truth. It's also linked to the idea of hidden variables, many worlds, and consciousness as a trigger for reality. Some compare it to the double-slit experiment, where a photon behaves like a wave until you watch it, and then picks a side. Except here, it isn't a particle. It's a creature, something that forces you to confront the absurdity head-on. But the deeper question isn't about physics. It's about truth existing unobserved. Do things happen without being witnessed? Does knowledge create reality, or just describe it? In a courtroom, in politics, in belief systems, all of this echoes. If we don't see it, is it undefined? If no one checks, does it matter? And when someone finally looks, do they discover or decide? You're left with a sealed box and two realities that can't both exist, but somehow do. Your logic pushes in one direction, the math pushes back, and in the middle is a creature that was never meant to be there, trapped not by poison, but by philosophy. The point isn't to open the box, it's to realize that the box was never about the cat. It was always about you, standing there, uncertain, forced to choose between what you know and what you're allowed to admit is real. Wave-particle duality. You are standing in a darkened laboratory, the only light coming from a narrow slit across the room. Your breath is quiet, but your mind isn't. In front of you is a particle gun, something small and unassuming, designed to fire one electron at a time. You don't hear it move, you don't feel anything shift, but you know. Each shot could change how you understand reality itself. You press the button just once. One particle flies forward into the darkness, but something impossible is about to happen. This is the wave-particle duality paradox. It begins as a simple question: what is matter, what is light, really made of? You'd expect a particle to behave like a solid, like something that occupies a single place at a single time. You'd expect a wave to spread, to ripple, to interfere with itself. But when you stand here, in this silent room, watching electrons fired one by one through a slit, those expectations collide. You run the experiment the way common sense demands. You open two slits in the panel and fire particles individually. They should pass through one slit or the other and hit the screen behind them in two neat clusters. That's what any rational mind would predict. But that's not what happens. Over time, a striped pattern emerges. Not two clusters, but a series of bright and dark bands. An interference pattern, the kind you get when waves overlap. Except you didn't launch waves, you launched particles, one at a time. They weren't supposed to know about each other, let alone interfere. But the marks don't lie. They form a design that shouldn't exist. You think maybe the particles are bumping into each other, so you slow everything down. Fire them with long pauses in between. No change. The interference pattern still forms. It's as if each electron is somehow passing through both slits at once and interfering with itself. Now you decide to watch, to measure, to observe. You place detectors at the slits. Your goal is simple. Catch the particle in the act, see which slit it goes through, reveal the trick, solve the puzzle. But the moment you observe it, the moment you look, the pattern changes. The interference disappears. Two clusters appear on the screen, exactly as classical physics would expect. The electron chooses a path, slips through one slit, and hits the screen like any ordinary particle. The act of observing changes the outcome of reality. When you don't look, it behaves like a wave. When you do, it becomes a particle. The electron seems to know whether it's being watched. So which is it? A wave? A particle? Neither. Both. This paradox sits at the heart of quantum mechanics. It's a collision between intuition and reality. Waves spread, particles impact, yet light, electrons, even atoms can behave as both, switching roles depending on the experiment. You can't pin them down without changing the rules of the game. It's a paradox of observation, of knowledge, of existence itself. It echoes others, the Schrödinger's cat thought experiment, where the act of looking defines life or death, the double bind of self-reference, where knowing something alters what's being known. But here, the contradiction isn't philosophical, it's physical. What is the world made of if its building blocks refuse to settle on a single identity? If matter isn't truly solid, and waves aren't purely abstract, then the categories you rely on begin to dissolve. You start to question not just what exists, but what it means to exist unobserved. There are implications that stretch beyond physics. How much of reality is independent of perception, and how much is shaped by it? If knowledge changes the world, then every act of measurement is an intrusion. Every attempt to define becomes a distortion. You begin to wonder, is the universe hiding its true nature until someone asks the right question? Or is the question itself the distortion? You stand in the dark, the slit before you, the screen behind it quietly waiting. You lift your finger over the button again, because the paradox doesn't end with an answer, it ends with a decision. Look, and reality behaves one way. Look away, and it becomes something else. And so you ask yourself, in the silence of this room, was the electron ever a particle? Was it ever a wave? Or have you only ever seen what the act of seeing allows? The paradox doesn't resolve. It lingers like a ripple in the dark, waiting for you to observe it again. EPR Paradox. You're holding two dice. They look ordinary, painted white, black dots on each side, cool in your hands. You throw them into the air, they tumble, they land. But then, something strange. No matter how far apart they are, even if you take one die across the world, the moment one lands on a 6, the other instantly shows a 6 too. No rolling, no delay. It just knows. At that moment, your mind stutters. How could two objects separated by distance act as if they were one? This is the stage for the EPR paradox. Einstein, Podolsky, and Rosen posed this riddle in 1935. They were confronting something deeply unsettling about quantum physics, the idea of entanglement. Two particles, once linked, could influence each other instantly, faster than light, beyond space, beyond cause and effect as we normally understand them. Einstein hated this. He called it spooky action at a distance. Why spooky? Because it seemed to break the very rulebook of the universe. So imagine this. You have two particles, born together in the same quantum event. You send one left, across galaxies, the other right, across oceans. Each is spinning. But quantum physics says you don't know their spin until you measure it. It's not hidden, it's not waiting, it simply doesn't exist in a definite state until you look. Now here's the paradox. The instant you measure particle A, it chooses a spin, say, up. And at that exact same instant, no matter how far away, particle B reveals the opposite spin, down. Not a second later, not delayed, immediate. So, how does particle B know what particle A did? You might think maybe they had the outcome predetermined, like dice secretly loaded before you rolled them. But quantum theory insists they didn't. Before measurement, both spins were undefined, floating in probability. Only when you look did the universe collapse into a definite outcome. If that's true, then information traveled instantly across space, faster than light, a violation of relativity itself. But if Einstein was right, that physics must be local, that nothing can leap across the void faster than light, then quantum mechanics must be incomplete. Some hidden variables must be pulling the strings. Yet, decades later, experiments proved otherwise. Bell's theorem, aspects experiments, and countless replications revealed that quantum entanglement is real. No hidden script, no secret dice. The universe really does link particles in ways that seem to bypass distance itself. At its heart, the EPR paradox is a paradox of reality itself. Either information can travel faster than light, or particles somehow remain connected in ways that break our classical idea of separateness. It's not just physics, it's a challenge to how we understand knowledge, causality, even individuality. Are two entangled particles truly separate? Or are they one system, stretched across the universe like threads of the same fabric? And if particles can share a state across light years, what does that say about you, about me, about the boundaries we think define us? We call it a paradox because it resists resolution. Einstein wanted certainty. a clean and ordered reality. Quantum mechanics gave us something else, a universe that's relational, probabilistic, deeply strange. Entanglement remains not just a puzzle of physics, but a mirror held up to our assumptions about truth, distance, and what it means to be connected. And so the EPR paradox leaves you here, standing at the edge of logic and mystery, staring into a universe that whispers, separation may only be an illusion. Black hole, information paradox. You're drifting at the edge of something that shouldn't exist, a cosmic void, darker than thought itself. Behind you, the stars still whisper their ancient light. Ahead, there's only the event horizon, silent, devouring, absolute. You feel it before you understand it. Once you cross that line, nothing you are, your memories, atoms, history, can ever return. And yet, physics insists that nothing can truly disappear. In this moment, you're not just facing a black hole. You're standing at the edge of a contradiction. This is the black hole information paradox. At first, it sounds like a problem only theorists would care about, something tucked into equations and chalk dust. But it isn't. This paradox doesn't just question what happens to objects that fall into darkness. It challenges the foundation of how reality keeps its books. Because according to quantum mechanics, information can't be destroyed. Every particle, every arrangement of matter, every configuration of energy is part of an unbreakable record. The universe may scramble information, but it never erases it. But black holes, they seem to disagree. Imagine this. You throw a book into a black hole. The words, the ink, the pages, gone. You toss in something more personal. Your name, your story, your DNA. The event horizon seals it all off. No signal, no photon, no trace can return. From the outside, everything is erased. And black holes don't last forever. Stephen Hawking showed that they emit radiation. Random, thermal energy we now call Hawking radiation. Over astonishing timescales, a black hole evaporates entirely, leaving nothing behind but empty space. So here are the only two possibilities, and both of them break something fundamental. First scenario, the black hole destroys the information. It falls in, the black hole radiates away into nothing, and everything that went into it, every particle's identity, every physical state is wiped clean. But this violates quantum theory, which has never been wrong in any experiment we've ever conducted. If information can be lost, the rules that govern reality start to break. Unitarity collapses. Predictability collapses with it. Second scenario, the information escapes somehow. But Hawking radiation is thermal, featureless, patternless. It contains no structure, no imprints of what fell in. It's like trying to reconstruct a library from the temperature of the ashes. If the information does emerge, then either the radiation is secretly encoded with impossible precision, or something is leaking out from beyond the event horizon, something that's not supposed to happen. So whatever you choose, the laws of physics turn on themselves. This is a paradox of unitarity versus gravity, a clash between the smooth geometry of space-time and the rigid bookkeeping of quantum mechanics. General relativity says the horizon hides everything. Quantum mechanics says the universe is a hoarder that deletes nothing. To glimpse how deep this goes, compare it to the classical paradoxes of logic, like the liar paradox, where a statement cancels its own meaning. But here, it's not words contradicting words. It's the universe contradicting itself. And then the reflection creeps in. This isn't really about black holes. It's about whether reality can lose track of itself, whether destruction is real or only transformation, whether the universe is a storyteller or a shredder. Maybe the horizon is not a boundary, but a disguise. Maybe the information is smeared across the surface in a holographic imprint. Maybe the radiation is not random after all, just coded beyond our comprehension. Or maybe space-time itself breaks down, and the rules we thought were absolute never were. But now you're standing at that edge again. Your atoms, your memories, your signal to the cosmos, do they vanish? Or do they whisper themselves into the radiation as the black hole dies? There is no clean answer, only a question that stares back across the void. Because the paradox isn't asking what happens to matter. It's asking what happens to meaning. And until physics can decide whether the universe forgets, the event horizon remains not just a boundary in space, but in truth itself. Maxwell's demon. You're in a silent laboratory, surrounded by glass chambers and the low hum of unseen machines. Two identical containers of gas sit before you, connected by a tiny door no wider than a coin. At first, everything is still. Molecules drifting in every direction, endlessly colliding, obeying the rhythm of chaos. But then you notice something impossible. There's something at the door. Not a creature of flesh, but of intent. No bigger than a thought, no louder than a breath. It waits, watching each molecule like a sniper tracking heat signatures in the dark. When a fast-moving molecule rushes toward the opening from the left, the door flicks open just long enough to let it through. When a slow one approaches from the right, it slips silently into the opposite chamber. Bit by bit, the left side grows cooler, while the right side heats up. Order from disorder. Separation without effort. Entropy reversed. Only now do you realize what you're looking at. You are witnessing Maxwell's demon. It was never meant to be a creature. It was a challenge, a thought experiment posed in 1867 by James Clerk Maxwell, a scientist who understood the rules of the physical world so deeply that he dared to break them in imagination. The demon is not a monster. It is a question wrapped in a contradiction. Can intelligence cheat the laws of thermodynamics? To understand the trap, you need to walk through the logic step by step. In normal physics, heat flows from hot things to cold things. Entropy, the measure of disorder, always increases. It's not just a guideline. It's the second law of thermodynamics, the backbone of engines, weather, biology, even time itself. But the demon doesn't break the rules by force. It does something more disturbing. It uses knowledge. If it allows only fast molecules through one way and slow ones the other, it effectively creates a temperature difference without expending any energy. In theory, you could power a machine with that difference. A perpetual motion engine born not from fuel, but from information. So the question becomes, where's the cost? What is the price of intelligence? Now imagine two possibilities. In the first scenario, the demon acts freely. It observes, sorts, and separates without lifting a physical weight or spending a measurable unit of energy. If that's true, then the second law collapses. Entropy becomes negotiable. The universe is no longer a closed system, but a loophole waiting to be exploited by anything clever enough to see it. In the second scenario, you dig deeper. You ask, what does it take to watch every molecule? To decide? To store the information of each movement and act on it? You begin to suspect that thinking isn't free, that information itself carries entropy. The demon doesn't break the second law. It hides the cost in the shadows of memory, measurement, and erasure. Now the paradox sharpens. Is entropy a property of matter or of knowledge? When something becomes ordered, is the disorder simply transferred somewhere else? And if the demon must erase its memory to continue sorting, does that act burn as much energy as it supposedly saved? This is not just a trick of physics. It's a whisper about the nature of intelligence, control, and systems we think we understand. In your life, you've seen versions of this demon, not in laboratories, but in algorithms that filter data, in institutions that sort people, in decisions that seem effortless but leave invisible costs behind. The paradox doesn't end with gas and molecules. It reaches into economics, psychology, computation, even ethics. If knowledge can change the fate of a system, who or what pays for that control? Every choice you make reorganizes some part of reality, even if you don't see the entropy you displace. And so you stand there, watching this unseen attendant at the door of two worlds. It does nothing violent. It rearranges. It selects. It observes. And in doing so, it dares you to answer a question that science still wrestles with. What is the true price of information? The demon will not tell you. That's not its purpose. Its existence is a mirror held up to the laws you trust. Some say entropy survives untouched, hidden in the cost of thought. Others suspect the universe may not be as closed as we claim. But resolution isn't the point. The point is this: some things break not by force, but by understanding. And sometimes the most powerful violation is the one that looks like perfect obedience. Olber's Paradox. You step outside on a quiet night. No streetlights, no cars, no distant hum of the city. Just darkness stretching in every direction. Your eyes adjust, searching the sky, waiting for something to emerge out of the black. A few stars appear, pinpricks of light scattered in the void. But then a strange thought settles in your mind, slow and unsettling. If the universe is filled with stars, trillions of them across infinite space, then why isn't the night sky blazing with light? Why is everything around you submerged in darkness instead of a cosmic glow that drowns the world in brilliance? At this moment, you aren't just stargazing. You're standing inside a contradiction. This is Olber's paradox. It looks simple at first glance. If the universe is infinite and filled uniformly with stars, every line of sight should eventually hit the surface of a star. There shouldn't be gaps, no dark patches, no empty void to stare into. The entire sky should be as bright as the surface of the sun, not metaphorically, literally. Every star would contribute its light, and the cumulative effect would erase the concept of night altogether. Yet here you are, surrounded by darkness, so vast you can almost hear it. So what's going on? Let's break the possibilities. In one scenario, you imagine looking in any direction. Immediately, your line of sight crosses a distant star. Behind that star, more stars. Behind those, infinitely more. Even if the light from each one weakens with distance, the sheer number of them should overwhelm that decay. An infinity of stars stacked into every viewpoint means no shadow survives. The sky should be a flaming mosaic of light. But that's not what you see. Instead, the vast majority of the sky is black. You can count the brightest stars. Darkness dominates. Your senses report something that logic rejects. In another scenario, maybe the stars are just too far. Perhaps light hasn't had time to reach you. But that implies time has boundaries, that light has only been traveling for so long. If the universe were eternal, light would have had infinite time to arrive from every direction. Infinity erases distance. Eternity dissolves delay. You start to realize the trap isn't about observation, it's about assumption. Olber's paradox is a collision between three ideas that seem perfectly reasonable on their own. The universe is infinite. Stars are distributed throughout it, and it has always existed. Put together, they create a contradiction you can't ignore. It's not like Zeno slowing an arrow mid-flight, or a liar contradicting himself with a sentence. This is a paradox made of darkness and silence, a contradiction hidden in plain sight. At its core, it's a paradox of infinity, time, and visibility, a cousin to the dark night sky problem, and a distant relative of the idea that infinite processes lead to impossible conclusions. You don't stumble into it through clever wordplay. You arrive there through your own eyes. And then the deeper reflections begin. If the sky is dark, something fundamental about your assumptions must be wrong. You're forced to question the nature of time, the age of the universe, the existence of cosmic boundaries, the absorption of light, the expansion of space. The paradox whispers that darkness isn't empty, it's evidence. Silence, it suggests, is sometimes the loudest correction. You're no longer just looking upward. You're staring into the structure of reality, into beginnings, into limits, into the idea that infinity on paper behaves nothing like infinity in existence. But here's the more disquieting thought. You don't solve Olber's paradox simply by naming causes. You experience it as a reminder that your intuitions about space, time, and forever might be illusions. That infinity can't be trusted just because it sounds neat in theory. That darkness itself might be the shadow of truths you haven't uncovered yet. So the night remains, cold, black, eerily quiet. And you, standing beneath it, start to understand. The paradox isn't asking for an answer. It's forcing you to confront the gap between what you think the universe should be and what it truly is. Because maybe the question was never, why is the sky dark? Maybe the real question is why you ever expected it to be bright. Quantum Zeno effect. You're alone in a silent laboratory, surrounded by glass, metal, and the constant hum of machines you don't entirely understand. In front of you, something impossibly small, an unstable quantum particle, is poised to change its state at any moment. It exists in a delicate balance, like a candle flame trembling in a breeze you can't feel. Your breath is steady, your eyes fixed, but your thoughts are louder than the silence around you. All you've been asked to do is watch. There's a monitor recording every nanosecond, every fluctuation, every sign that the particle might finally decay. You don't intervene. You don't alter its environment. You simply observe. Yet with every act of looking, something strange happens. The decay never comes. Only now do you realize that you've stepped into the quantum Zeno effect. It sounds like theoretical poetry, the idea that the mere act of observing can freeze a moment in time. Named after the ancient philosopher Zeno, who imagined arrows that could never truly move if reality were observed in infinitely small slices. This paradox takes that metaphor and stitches it into the laws of physics. Here, watching isn't passive. Watching is interference. Imagine this particle, left alone, would naturally evolve, decay into something else, transition to another state, complete the path probability has written for it. But in your presence, something interferes. Every time you measure it, every time you check, you collapse its wave function back into exactly what it was. Observation becomes a reset button, and so instead of moving forward, it stays suspended, as if time is being forced to wait for you to look away. But here's the unsettling part. You weren't trying to stop anything. You were only trying to know. So what's really happening here? In one scenario, you allow the particle to evolve on its own. Over a measurable time, it changes, like any unstable system should. Physics proceeds naturally. But in another scenario, you observe it repeatedly, so frequently that its evolution is interrupted again and again. The closer your measurements get to continuous observation, the more likely it becomes that the particle will not decay at all. You are not destroying it. You are delaying the future by acknowledging the present. This isn't intuition. Experiments confirm it. At the quantum level, measurement is not a neutral act. It is participation disguised as attention. And in that act, probability itself bends. So what kind of paradox is this? It's not merely logical, like a word puzzle. It's a paradox of time, measurement, and existence. It echoes Zeno's ancient thought experiments about motion being impossible if you divide it endlessly. But here, the setting isn't philosophy, it's quantum mechanics. The contradiction rests between what should happen naturally and what actually happens when you look too closely. And yet the implications stretch far beyond particles. Think about consciousness and control. Think about how systems change only when left alone, and how scrutiny alters the outcome. Surveillance modifies behavior. Constant monitoring freezes growth, evolution, rebellion, decay, whatever was meant to unfold. Reality itself becomes performative under observation. Hospitals have documented something similar. Patients whose unstable conditions seem to last longer during frequent check-ins. Financial markets stall under constant regulatory watch. Creativity suffocates when evaluated too early or too often. Even trust becomes fragile when every action is measured. When you watch something closely enough, you might not just understand it, you might prevent it from becoming anything else. And so the quantum Zeno effect turns a quiet question into a cosmic one. Does reality have freedom when no one is looking, and does observation steal that freedom away? You came here to study a particle. Instead, you're staring at the edge of a deeper truth, that attention can be a cage disguised as curiosity. The paradox doesn't resolve, it lingers, because the more you try to witness change, the more you might be stopping it. And the moment you look away, you have no guarantee of what the world will become when you're not watching. In the end, you're left with a choice that isn't really a choice. Keep observing and freeze the moment, or step back and let reality unfold without you. Either way, the question remains, waiting in the dark behind the monitor. How much of the universe changes only when you're not there to see it? Hilbert's Hotel, infinite rooms. You arrive at the edge of a winding desert road just as the sun dips beneath the horizon. The air is cold, the sky bruised purple, and in the distance, a towering hotel glows like a cathedral of windows. You're exhausted, dust on your shoes, night pressing in. As you push through the enormous glass doors, a clerk with a hollow smile greets you with impossible calm and says, "Welcome, we've been expecting you." Your eyes drift across the grand lobby, portraits that seem older than memory, chandeliers that burn but cast no shadows. You ask the question anyone would ask this late. "Do you have a room available?" The man behind the desk doesn't hesitate. "We are fully occupied," he says. "Every room is taken. But don't worry, we always have space." And at that moment, something in your mind stutters. How can a place be full and still have room for you? This is the beginning of Hilbert's Hotel, a paradox born not from superstition or magic, but from the cold logic of infinity. Imagine the hotel has an infinite number of rooms, numbered 1, 2, 3, and so on, extending endlessly down corridors you can't see the end of. Every room is full, not a single vacancy. Yet the clerk snaps his fingers and says, "We'll move the guest in room 1 to room 2, the guest in room 2 to room 3 to room 4. Each guest shifts forward exactly one room. Just like that, room 1 is empty. A space has opened up without removing a soul. A full hotel has made room for you by rearranging infinity. But now the door swings open again. A second traveller arrives, then 10 more, then 1,000. The clerk doesn't flinch. He instructs each current guest to move from room N to room N plus 1,000. Suddenly, rooms 1 through 1,000 are free. 1,000 new arrivals, all accommodated by a place that was already full. And the night isn't done with you yet. A bus pulls up outside. Not one bus, not a fleet, but an infinite convoy. Each bus containing an infinite number of passengers. A torrent of arrivals with no end. You glance at the clerk, waiting for panic. He simply picks up a leather-bound ledger and begins assigning new locations. Each existing guest moves to a room number doubled, room 1 to 2, 2 to 4, 3 to 6, and on without limit. Now every even-numbered room is occupied. Every odd-numbered room, also infinite in count, stands ready for the infinite buses unloading infinite travellers. What's happening here isn't a trick of architecture. It's not sorcery, or technology, or folding space. It is a confrontation with the logic of actual infinity, something the human brain is not wired to grasp. In your world, a place that is full cannot take more. Capacity is finite. Resources are limited. Full is final. But in Hilbert's Hotel, infinity laughs at that intuition. Here, subtraction doesn't reduce. Addition doesn't overwhelm. You can remove an infinite number of guests and the hotel still has infinitely many. You can add infinitely more, and it still will not break. This is not just a puzzle. It's a paradox of quantity and meaning. Infinity behaves like a number until you treat it like one. Then it fractures logic. At its core, this is a paradox of actual infinity, the kind mathematician David Hilbert used to expose the bizarre consequences of treating infinity not as an idea, but as a completed, manipulable object. Unlike a potential infinity, something that grows but is never finished, this hotel imagines infinity as already built, already total, already real, and that's where everything becomes beautifully unsettling. You might compare it to Zeno's paradoxes, where infinite steps block motion, or the Banach-Tarski Paradox, where a single sphere can be split and reassembled into two identical ones. In each case, logic doesn't fail, intuition does. But the implications go beyond thought experiments. If infinity works like Hilbert's hotel, what does it say about time, space, computation, or even the universe? Can something be complete and unbounded at the same time? Can limits exist when everything within the system defies limitation? Think of overcrowding, scarcity, fairness. If a hotel can make room for everyone by shifting the problem upward, is the solution real or just rearranged contradiction? If something infinite is full, what is fullness? If every spot is occupied, yet accommodation is always possible, what does occupied even mean? And what about identity? If a person moves from one room to the next, and then again and again, at what point have they been displaced beyond recognition? Does infinity erase continuity, or merely stretch it beyond perception? The truth is, the paradox doesn't break mathematics. It exposes the way mathematics clashes with instinct. This is not a flaw in the concept of infinity. It's a flaw in the way we try to fit it inside minds built for counting, not for eternity. So you stand in the lobby, the clerk sliding a key across the polished counter. The hotel that is full has made room for you, and for anyone else who might come after. There will always be a room, because the rooms do not end. Nothing needs to be removed. Nothing needs to be rejected. Infinity absorbs everything without strain. You step toward the elevator, unsure whether you're checking in or disappearing into a concept. And as the doors close, you realize, in a place with no end, even fullness is an illusion. The limit isn't in the hotel. It's in the mind trying to understand it. Dichotomy Paradox. You take a step forward. Your foot hovers just above the ground, ready to land, but something strange grips your mind. Before you can place it down, a thought interrupts you. Before you walk across this room, you must first reach halfway. And before you reach halfway, you must cover half of that. And before that, half again. On and on, each step divided, each distance split into smaller and smaller pieces. Suddenly, the room feels endless. Your destination, no matter how close, retreats into infinity. This is Zeno's Dichotomy Paradox. At first, it seems like a simple riddle about movement, but beneath the surface, it is a logical snare. A puzzle that questions not just motion, but the very fabric of space, time, and reality itself. Imagine you want to walk to the door across from you. The paradox begins with a simple demand. Before you can finish the journey, you must complete half of it. Fine, you think. You take that step. But now another demand appears. Before you can finish the remaining half, you must first complete half of that, and half again. Each step becomes infinitely divided. In this scenario, motion itself seems impossible, because if space can always be cut in half, then you must perform an infinite number of tasks just to move a finite distance. The door may be right in front of you, but logically, you can never arrive. But here's the contradiction. In the real world, you do arrive. You walk, you run, you travel across cities and oceans. Planes land, arrows fly. The evidence of your senses says movement happens every moment, yet Zeno's reasoning insists it shouldn't. So what's really going on here? The dichotomy paradox belongs to a family of paradoxes that deal with infinity. It's not about whether you can walk, but whether logic can explain how you walk. When you cut a journey into infinite pieces, it seems you create infinite tasks, and no finite being can complete an infinite number of tasks. This is where the tension lies. Infinity feels both untouchable and unavoidable. Zeno forces you to confront the uncomfortable possibility that what seems obvious, motion, is not as simple as it appears. Think of it like this: the paradox is less about your body moving and more about your mind's struggle with infinity. In math, infinite series can add up to finite sums. 1/2 plus 1/4 plus 1/8 plus 1/16 approaches 1. So in theory, all those endless halves can converge into a single completed step. But here's the catch. That's a mathematical explanation, not a physical one. It uses abstraction to patch the hole. The paradox remains, whispering that perhaps our reasoning can't fully capture the world we move through. And so, the dichotomy paradox becomes more than a puzzle about walking. It becomes a mirror for human thought. It asks, can logic capture reality? Can infinity truly exist in the world, or is it only a ghost in our minds? If space and time are infinitely divisible, then every motion is haunted by infinity. But if they are not, then reality has limits, edges, grains, like pixels on a screen. Which truth feels more unsettling? In philosophy, Zeno's paradox echoes into debates about calculus, physics, and metaphysics. Is the universe continuous, flowing smoothly without breaks? Or is it discrete, built from indivisible units of time and space? When you move, are you gliding across a seamless fabric? Or are you leaping from instant to instant, frame to frame, without ever realizing the jumps? The dichotomy paradox doesn't want to be solved. That's its trick. It doesn't stop you from walking across the room. It stops you from walking away from the question. And in that way, it lingers. So the next time you cross a room or take a step forward, remember, logically, you should never get there, but you always do. And maybe that contradiction is the real paradox we're living in. Gabriel's horn. You're standing in an endless white expanse. There are no walls, no ceiling, no sky, just a horizon that never arrives. In front of you, someone places a long, twisted object on the ground. It starts wide near your feet, like the bell of a trumpet, then stretches forward and keeps stretching. You walk toward its narrowing body, expecting an endpoint, but the object thins and thins and thins until it's no thicker than a wire, yet it never actually stops. It just keeps reaching into the distance, forever. Your mind tries to anchor to something familiar, a horn, a tunnel, a funnel, anything with a front and back. But this thing refuses to end. You run your fingers along its surface, and it feels smooth and solid, real, tangible, and then someone hands you a paintbrush. They say, cover the entire outside of this horn with a single coat of paint. It sounds impossible. The shape goes on without limit, a trumpet that grows infinitely long as it narrows to nothing. You protest, but they reassure you. You can. Because, they say, the outside of this impossible horn takes up only a limited amount of space. Enough to paint, enough to coat, enough to cover. And yet, if you look inside this horn, something even stranger is happening. Welcome to Gabriel's horn. This isn't just a clever thought experiment. It's a direct assault on what you think infinity is, on what space means, on what it means for something to be endless. The paradox lies in its shape, a form that stretches on forever, yet somehow has an exterior small enough to paint, but an interior so vast you could pour and never fill it. Imagine two tasks, painting the outside and filling the inside. Task 1, you cover its surface with paint, a finite job, measurable, doable, no tricks. Task 2, you attempt to fill the horn with water, or sand, or air, or anything that takes up actual volume. You pour until your arms ache, until your back breaks, until centuries pass. But the horn keeps swallowing it. The inside refuses to be filled. It is bottomless, not because it's large, but because it never ends. Somehow, something with an outside small enough to coat has an inside large enough to consume the infinite. So how is this even possible? The horn trick is built on the way size behaves when something narrows faster than it stretches. The outside, what you touch, paint, or wrap, compresses. It converges. It calms down. But the inside, it stretches deeper than your imagination can follow. Infinity hides in that gap between what shrinks and what extends. You're held in tension between two truths that cannot both feel right, that the outside is limited and the inside is not. It's like owning a house with only one wall to paint, but an interior with rooms that go on forever, or a well whose opening is the size of a coin, but whose depth drops through eternity. Gabriel's horn sits in the family of paradoxes about infinity, not infinity as a number, but infinity as a behavior. It stands beside things like Achilles chasing the tortoise, or the hotel that's always full, yet always has room. Except this one isn't about motion or guests. It's about how something can be small in one sense and limitless in another. But now the question grows deeper. Is infinity real, or just a story you tell to describe your inability to measure? What does it mean for something to take up no space at its end, yet extend without end? What does it mean for a shape to be complete when you can never reach its completion? And beyond the math, there's a human mirror hiding here. Think of how people consume information, finite attention, infinite feed, how you can skim the surface of a subject and feel you've covered it, while its depths go on beyond anything you could ever hold. Think of systems that appear small from the outside, but contain histories, consequences, or complexities with no bottom. This horn, this shape, is a symbol of contradiction we live with all the time, that the outside of something can seem manageable, paintable, knowable, even while its interior stretches past reason. Because the paradox of Gabriel's horn isn't trying to be solved, it's trying to whisper something unsettling. You can finish covering the surface of an idea, a life, a world, but that doesn't mean you've come close to filling it, and maybe you never will. Coastline Paradox. You're standing at the edge of the world, not metaphorically, but at the place where land gives up its certainty to the slow, relentless pull of the sea. The wind cuts across your face, sharp and salt-heavy, and the sound of the waves feels ancient, like something older than thought. From where you stand, the coastline looks like a single sweeping curve, something you could trace with your finger, something that seems to have shape and boundary. But the longer you stare, the more it starts to blur. Every rock, every inlet, every hidden cove whispers a question. Where does the line really begin? And where does it end? Only after you've taken it in. The cliffs, the jagged stones, the sand washed smooth by tides. Do you realize this is not just scenery? You're standing inside a paradox. It's called the Coastline Paradox, and it asks a question that seems simple on the surface. How long is a coastline? But the moment you try to answer, the ground shifts beneath your feet, because the answer isn't constant, isn't stable. It moves, shrinking, stretching, expanding into infinity, depending entirely on how you choose to measure it. Imagine you walk along the shore with a long measuring stick, say 100 kilometers. You trace the broad shape of the land, a cape here, a bay there. You get a result. It feels official, mathematical. But then you try again with a shorter stick, 10 kilometers. Suddenly you're measuring more of the curves, bending into more of the shoreline's bends and folds. The coastline grows. The number gets bigger, not because the land changed, but because your resolution did. Try again with a 1 kilometer measure. Now you're tracing even smaller crevices, miniature peninsulas, subtle fractures in the rock you never saw before. The coastline stretches further. Keep going. Use a meter, a centimeter, a grain of sand. At every step down in scale, the coastline expands like something alive, something fractal. In theory, if you keep zooming in, measuring every pebble, every ripple, every grain of rock, you never stop. The length approaches infinity. A finite country could have a perimeter longer than the orbit of the moon, if your ruler is small enough. So what's happening here? This isn't a trick of geography. It's a paradox of measurement, a collision between physical reality and mathematical abstraction. The Coastline Paradox reveals that some shapes in nature don't play by Euclid's rules. They aren't smooth, they aren't clean, and they don't collapse neatly into straight lines or perfect curves. The closer you look, the more detail you uncover, and the more impossible it becomes to assign a definite boundary. You're not just measuring a line, you're measuring roughness, chaos, and infinite complexity. This is where fractal geometry steps in. The same logic that governs snowflakes, lungs, lightning, and galaxies. Like Zeno's paradox, which chops motion into smaller and smaller steps, the coastline forces you to confront the idea that infinity doesn't always live in the heavens. Sometimes it hides in the cracks of a rock or in the curl of a wave. But the paradox isn't just mathematical, it's philosophical. It asks you, how do you define something that changes every time you try to quantify it? When does measurement reveal truth, and when does it distort it? Maps, borders, property lines, all rely on the idea that the world can be pinned down with numbers and lines. Yet the world itself resists being flattened. Nature doesn't speak in straight edges. It speaks in fragments, in fractals, in patterns that repeat without ever becoming identical. And so you're left with a quiet realization. The coastline doesn't have one length. It has infinitely many, each one emerging from the lens you use to see it. The boundary between land and sea isn't a line at all. It's a negotiation, shifting with perspective, resolution, and time itself. You came here thinking the shore was solid, measurable, definite, but you walk away with something else. A suspicion that certainty might be an illusion we draw on top of complexity. The coastline doesn't bend to your measurements bend to it. And somewhere, beneath the roar of the waves and the silence of the rocks, a question lingers. If something as real as a shoreline can stretch toward infinity, what else have you been measuring wrong? Banach-Tarski Paradox. You hold a smooth, perfect sphere in your hands, solid, unbroken, real. Maybe it's a ball, maybe a planet in miniature, maybe just a shape your mind rests on for a moment. Its surface is cold, its weight familiar. Now imagine someone tells you they can take this exact sphere, cut it apart into a few pieces, and then reassemble those pieces into two identical spheres of the same size, without stretching them, without adding anything, without shrinking anything. The same sphere, duplicated, perfectly. That's not a magic trick. That's the Banach-Tarski Paradox. It sounds like a violation of reality itself, something from a dream, or worse, a loophole in existence you were never meant to notice. But the claim is precise. From one solid sphere, you create two, or three, or an infinite number of them, all exactly the same size as the original. So how can that be? The paradox begins with a promise that feels innocent. Take an object and break it into pieces. Nothing strange, until you realize these aren't normal pieces. They're not chunks you could hold. They're not slices, layers, fragments, or even dust. They're made of points. Points so scrambled, so scattered, so impossibly arranged that they cannot be visualized, cannot be drawn, cannot even be constructed in reality. These pieces exist only because mathematics allows them to. Once the sphere is broken into these bizarre sets, just a handful of them, not billions, you rotate them, shift them, and then reassemble. And out of this distortion of logic, two full spheres appear, the exact same size as the original. The rules haven't changed. You haven't stretched anything. You haven't created matter. You've just rearranged what was already there. But the result is impossible if you think in terms of atoms, space, or physical substance. So here's the catch. This paradox lives in pure mathematics, not physics. It relies on something called the axiom of choice, a principle that allows you to select elements from infinitely many sets, even when there's no explicit way to name or describe them. It's a tool mathematicians use all the time, But hidden inside it is this disturbing consequence. Objects can be taken apart and rebuilt in ways no physical universe would allow. In the physical world, matter has structure. Atoms have volume. Energy must be conserved. But here, in the abstract world of infinite sets, structure dissolves. A sphere isn't made of particles. It's made of uncountable points, each with no size at all. And when you shatter something built from those, the pieces don't behave like anything you've ever touched. It's like trying to cut a shadow. You don't end up with halves. You end up with something that was never solid to begin with. The Banach-Tarski Paradox doesn't just bend intuition, it devours it. It tells you that duplication is possible without creation, that infinity hides inside the finite, and that the rules of logic don't always respect the rules of reality. And it forces a darker question. If something can be proven true in mathematics, but can never exist in the physical world, which one is closer to the truth? Do we trust the axioms that let us build these contradictions, or do we reject them, even if it means dismantling the foundations beneath modern math? Maybe the paradox isn't about spheres at all. Maybe it's about the limits of comprehension, about how far ideas can go once they're unshackled from the world that birthed them. You began with one perfect sphere. You ended with two. And nothing broke, except certainty. Monty Paradox. You're on a stage you never meant to be on. The lights are too bright, the applause too loud, and yet everyone around you is waiting for a decision only you can make. 3 doors stand before you, towering, polished, and ominously quiet. Behind one of them is everything you hope to win: a car, a future, the proof that you made the right call. Behind the other two, disappointment disguised as goats. You pick a door, not because you know anything, but because the clock is ticking and the world is staring. The host smiles, not a friendly smile, but the kind that knows more than you do. He strolls past your choice without opening it, walks to one of the other two, and reveals a goat. A clean distraction, a surgical strike on your certainty. And now he turns to you. You can stay with your first pick, or switch. Your breath stalls. The audience shifts in their seats. You can feel the weight of their anticipation pressing against your skin. You made a choice, but now you're being asked if you trust it. The door in front of you hasn't changed, but everything else has. You're no longer choosing a door. You're choosing a philosophy. This is the Monty Paradox. At first glance, it seems like a simple game show dilemma, a 50-50, right? 2 doors left, 1 win, 1 loss. But something is wrong with the math your instincts are feeding you. Let's rewind the moment. When you first chose, you had a 1 in 3 chance of being correct. 1 winning door, 2 losing ones. That part was obvious. But when the host opened a door with a goat, on purpose, with full knowledge of what lay behind, he didn't narrow your odds. He narrowed the world around them. If your first choice was wrong, and statistically, most first choices are, then switching doesn't just give you another shot, it hands you the correct door. But what if you don't switch? In that case, you're still clinging to your original 1 in 3 chance, hoping that your random guess beat probability itself. That means switching isn't a gamble. It's strategy disguised as betrayal of instinct. Yet your intuition doesn't agree. Something inside you rebels, because to switch is to admit you were probably wrong, and to stay is to risk being stubborn in front of everyone watching. This paradox is a trap built from probability and perception. Your mind wants symmetry. 2 doors, 2 outcomes, 50-50. But the game was never symmetrical. It started lopsided and stayed that way. The host's action didn't balance the scales. It tilted them further. It belongs to a family of paradoxes where knowledge bends the math, where revealing information changes the meaning of a choice rather than the choice itself. Like the Sleeping Beauty problem or the 2 envelopes paradox, it shows how logic mutates when uncertainty collides with selective insight. And it goes deeper than games. How many decisions in your life feel like coin flips, when in truth, They're rigged by unseen context. How often do you cling to a first choice? Not because it's rational, but because abandoning it feels like admitting defeat. When someone reveals a piece of the puzzle, do you update your belief or defend it harder? The Monty Paradox isn't just about probability. It's about ego, trust, regret. It exposes the uncomfortable truth that sometimes switching sides after new information isn't weakness. It's alignment with reality. But here's the catch. Certainty never announces itself. You're still standing before two doors. You're still being watched. The host says nothing. The moment stretches. Do you change your mind or defend it? In the end, the game show lights don't matter. The goats don't matter. What matters is the quiet war between instinct and reason that plays out in the silence before your answer. And the door won't open until you choose. Prisoner's dilemma. You're sitting alone in a windowless room. The air is still, heavy with the quiet hum of electricity. A metal table separates you from the door you were led through just minutes ago. Your pulse hasn't quite slowed down. Then it opens again. A detective walks in, calm, almost gentle, and sets a single sheet of paper in front of you. They tell you something you didn't expect. Your partner has already been taken into another room. You won't see them. You won't speak to them. Whatever happens next depends on one decision, yours. But before you can ask a question, the options are laid bare. If you stay silent and your partner stays silent, you both walk away with a minor sentence. Cooperation through silence. That's the best case scenario. But if you stay silent while they talk, you take the full blame. They get a clean slate. You don't. And here's the twist. If you talk, if you betray them, and they don't, you walk free while they take the fall. But if you both confess, the system punishes your mutual distrust. You both get time, not the worst sentence, but worse than if you trusted each other. You've just stepped into the prisoner's dilemma. It's not presented to you as a puzzle. It arrives as a choice with a clock ticking behind it. You're not being asked what's right. You're being asked what's safe. The logic seems simple at first. Protect yourself. Confess. Because silence is only rewarded if your partner is loyal, and loyalty is only rational if betrayal is off the table. But it isn't. You both know that. Now imagine it from the other room. They're being told the exact same thing. Same promises. Same threats. Same math. You can't signal them. You can't predict them. You can only try to outthink someone who's trying to outthink you in perfect isolation. And every path creates a contradiction. If you both act selfishly, to secure your own safety, you both suffer more than if you trusted each other. If you both act cooperatively, you win together, but only if neither of you doubts. The paradox isn't that there are choices, it's that the safest individual choice creates the worst collective outcome. This isn't a riddle about crime or consequence. It's a trap built from symmetry. You're not battling the law, you're battling the mirror of your own logic. The prisoner's dilemma is a paradox of rationality, game theory wrapped in psychological tension. It reveals how perfectly logical choices can lead to perfectly disastrous results. It's the same structure that governs arms races, business competition, betrayal in relationships, and the collapse of trust in political systems. And it gets darker. Even if both prisoners know that silence benefits them both, the fear of being the only one who stays quiet makes silence feel dangerous. Betrayal becomes the safe option. Logic becomes the enemy of the best outcome. That's what makes it so unsettling. It shows that cooperation is not defeated by malice, but by uncertainty. Even good intentions can be destroyed by the suspicion that someone else is thinking just like you. You might wonder if there's a way out, if perfect communication or perfect trust could fix the trap. But the dilemma was never about crime. It was about what happens when two minds try to predict each other under pressure. Every attempt to protect yourself tightens the noose around both of you. In the end, you're not really choosing between silence and confession. You're choosing between two visions of the world, one where trust survives pressure and one where it doesn't. And the paradox doesn't tell you which world you're living in. It just asks a question you can't escape. When your safety depends on someone else's silence, do you trust them, or do you make sure you don't lose alone? There's no resolution here, because the point was never to win. It was to realize that sometimes the most dangerous opponent is the version of you sitting in the other room. Newcomb's Paradox. You're standing in a silent white room. No windows, no clocks. Just a single metal table in front of you. On it, 2 boxes. The first is transparent, and inside it you can see exactly $1,000 in neatly stacked bills. The second is opaque, sealed, impossible to see into. You're told it might be empty, or it might hold $1 million. But here's the catch. Once you choose, you can't undo it. Your pulse is steady, your mind is anything but calm. Someone, or something, has already made a prediction about what you're going to do. You're told that a highly advanced predictor, a being or machine that has never been wrong, not once, looked at you before you entered this room. Based on its prediction, it either placed $1 million inside the opaque box, or nothing at all. If it predicted you would take only the opaque box, it rewarded that choice with the $1 million. But if it foresaw you taking both boxes, it left the opaque one empty. Now you stand here, and the decision is yours. Take just the opaque box, or take both. This is Newcomb's Paradox, one of the strangest battles between free will, prediction, and logic ever imagined. It's not a riddle about money. It's a tension between the idea that the future can already be set, and the belief that your choice in this moment still matters. Consider the first path. You decide to take only the opaque box. If the predictor truly anticipated this with perfect accuracy, then the $1 million is already waiting inside. You walk away richer than you ever dreamed. But it feels like an act of trust, almost submission, to something that has already judged you. But then there's the second path. You take both boxes. The reasoning is brutally straightforward. Whatever is in the opaque box is already there, independent of what you do now. The predictor can't reach back in time to change it, so why not take the transparent 1,000 as well? If the opaque box has the $1 million, you get both. If it's empty, at least you leave with something. It feels like the rational, dominant strategy. Yet here's the twist. If the predictor knew you would think that way, it left the opaque box empty before you ever laid eyes on it. Your cleverness becomes your loss. So suddenly, the strategy that should guarantee more money leads to less, and the choice that seems submissive is the one that wins big. What's really being tested here? This is a paradox of prediction versus free will, of causation that seems to run backward. You're not deciding what to do in a vacuum. You're deciding under the weight of a judgment that might have already accounted for your every thought. It echoes the prisoner's dilemma in game theory, the liar paradox in philosophy, and even determinism in physics. But here, the contradiction sits in your hands, disguised as a choice between one box or two. You're forced to ask yourself, is the future already written because it was predicted? Or does your choice now break the chain of expectation? If a being can know your decision with absolute certainty before you make it, are you really deciding, or only acting out what was always true? And deeper still, what does it say about rationality? There are philosophers who swear by one boxing, trust the predictor and take the $1 million. Others argue two boxing is logically unbeatable, take what's guaranteed. Each argument is airtight until you look at the other. Each collapses under the logic of the opposite side. The paradox lives in that unavoidable clash. This is the part that lingers long after you leave the room. How much of your life operates like this? Systems that predict your behavior shape the choices you believe you're making freely. Algorithms, governments, relationships, reputations. They preload rewards and consequences based on what they expect of you. You think you're deciding now, but maybe the decision was already built in before you saw the options. So you stand before the boxes, not just in a thought experiment, But in every interaction where expectation meets autonomy, you can pick the safe 1,000 or gamble on 1,000,000 that might already be gone. Either way, the paradox doesn't resolve when you choose. It waits in the silence after the choice is made. And maybe that's the point. You don't walk away with clarity. You walk away with a question that follows you. Were you choosing freely, or just doing what was always predicted? Two-envelope paradox. You are handed two envelopes. Both are identical, crisp, unassuming. One contains twice as much money as the other. Your heart flutters, excitement, hesitation, a quiet tension hanging in the air. You don't know which one is better. You don't know if choosing will make you richer or leave you wishing you hadn't moved at all. Your mind races. What would happen if you swapped or stayed with the first? This is the two-envelope paradox. At first glance, it seems simple, a choice between two options. But beneath that simplicity lies a subtle trap, a knot in logic that tugs at your reasoning. It is a paradox not of numbers, but of thought, probability, and expectation. You pick an envelope. Inside there is an amount, say $100. Now comes the temptation. Should you switch? One argument whispers in your mind. If this envelope holds $100, the other could hold $50 or $200. And if each scenario is equally likely, the expected value of swapping appears higher. Suddenly, swapping seems inevitable. But wait, step back. By the same logic, no matter what amount you see, swapping always seems better, even if you open the envelope and find $1,000 or $10. The reasoning repeats. This is where the paradox tightens its grip. Every choice seems advantageous, yet only one envelope can truly hold more. The very act of reasoning makes your decision loop endlessly. Consider the two scenarios. You stay with your envelope. You feel safe, but perhaps cheated. Thinking the other might have more. You switch. You might gain, or you might lose. Either way, the logic that led you to swap or to stay betrays you. It promises insight but delivers uncertainty. This paradox is a child of self-reference and expectation. It uses the mirror of probability to confuse intuition. Similar to the Monty problem, it twists your sense of risk and reward. Yet here, the trick is subtler. It is not about what you know, but about what you think you know. Philosophically, the two-envelope paradox forces us to confront the limits of reasoning. It asks, can expectation guide choice when knowledge is incomplete? Can logic exist without full context? In real life, we constantly make decisions under uncertainty, choosing investments, career paths, even moments of trust. The paradox whispers a warning. Sometimes, the rational mind becomes a loop, chasing its own tail, seduced by the promise of better outcomes that may not exist. It also touches on fairness and desire. We imagine the other envelope as more desirable, yet the envelopes themselves are indifferent. Our thinking assigns value, fear, hope, turning a simple choice into a battlefield of expectation. So what's really going on here? There is no solution, not in the sense of a definitive swap or stay. The two-envelope paradox exists to reveal something deeper, that logic, probability, and intuition can collide in ways that feel both precise and absurd. At the edge of this decision, you realize the truth is not in the envelopes, but in your mind. The paradox is a mirror, reflecting how we weigh risk, reason, and desire over and over, even when certainty is impossible. And as you hold your envelope, the other unopened, the choice lingers. It is a reminder. Some questions are meant not to be solved, but to be felt, considered, and remembered. A simple swap becomes a meditation on uncertainty, expectation, and the fragile architecture of thought. And so, you stand there, caught between two envelopes, two possibilities, and the quiet, persistent tug of the unknown. Sometimes, reflection itself is the only reward. Ship of Theseus. You are standing on the edge of a vast, restless harbour. The sea stretches endlessly before you. grey and churning under a cold wind that bites your skin. A ship drifts slowly into view, its hull polished, its sails taut, yet something feels different. You take a step closer, your heart catching. This is no ordinary ship. Every plank, every rope, every nail has been replaced over the years, one by one, until nothing remains of the vessel that first set sail. And yet, you recognize it. You know its name. You know its history. You have sailed on it, felt it creak beneath your feet, heard its timbers groan in the night. But is it still the same ship? This is the ship of Theseus Paradox. At first glance, it seems like a simple question of identity, but it isn't just about a boat. It's a profound inquiry into what it means for anything or anyone to remain themselves over time. The ship, like life, is constantly changing, yet we cling to labels, to continuity, to memory. Where does the self end and the replacement begin? Consider the first scenario. One by one, each piece of the ship is replaced. Every plank swapped, every sail mended, until the original ship exists only in memory. Can you still call it the same ship? It floats in the same harbour, carries the same name, and inspires the same awe. But is identity a matter of material or of form, function, and story? Now consider the second scenario. Imagine someone collects all the old planks and timbers, the discarded pieces replaced over the years, and painstakingly rebuilds a ship from them. Suddenly, there are two ships. One made entirely of new parts. One made entirely of the original parts. Which one is the true ship of Theseus? Both bear a claim to authenticity. Both can point to the history of the vessel, yet both cannot simultaneously be the same ship. Logic strains here. Your mind resists the contradiction, and yet it cannot escape it. The paradox is a problem of identity over time, a puzzle rooted in continuity, change, and self-reference. It resembles the liar paradox in its self-reflective quality. Just as a statement can claim its own falsity, a ship can claim its own identity while simultaneously being something new. Philosophers have wrestled with this for centuries, questioning whether objects, or even people, are defined by their material, their pattern, or their perception in the minds of observers. And this is where the reflection deepens. The ship of Theseus asks more than what is a ship. It asks, what is truth? What is memory? What do we value, the original substance or the story that survives it? In life, we replace ourselves constantly, from cells in our bodies to the habits that shape our character. We grow, adapt, and shed parts of ourselves, and yet we cling to an illusion of unbroken identity. It challenges our understanding of trust, of history, of justice, and of permanence in a world defined by impermanence. But now, you step back from the harbour. The wind gusts and the waves lap against the hull. Two ships drift before you, one rebuilt, one restored from fragments, and your mind strains to assign one true identity. Yet perhaps the point was never to decide. Perhaps the paradox is a mirror, reflecting the delicate tension between change and continuity, between reality and perception, between what is and what we believe endures. And as the sun dips below the horizon, painting the sea in bruised purples and fiery golds, you realize the question lingers, unanswered, unsettling, eternal. Sorites Paradox. You are holding a single grain of sand between your fingers. Tiny, almost invisible. You look at it and think, this is not a heap. You drop another grain, and another. Slowly, almost imperceptibly, the pile grows. Your mind races, because at what point does this collection of insignificant grains become something more? A heap, a mass, a truth. The question is simple, yet your intuition resists it. This is the Sorites Paradox. Sometimes called the paradox of the heap, it is a trap, not of mathematics but of language and logic. It forces us to confront the limits of our definitions. One grain is not a heap. 2 grains are not a heap. 10, 100, maybe even 1,000. Still we hesitate. And yet, somewhere along the line, we know a heap exists. But where exactly? Imagine two choices. You insist on counting, trying to pinpoint the exact moment. You draw a line, an arbitrary threshold, 1,000 grains, let's say. But then you realize, if 1,000 is a heap, then what about 999? Can you truly claim the difference of one grain transforms emptiness into substance? Each step you take backward, the certainty slips away. Or you abandon precision entirely. You embrace vagueness. A heap is vague, fluid, shifting with perspective, and yet this feels unsatisfying, like reasoning in a fog. Logic demands clarity, but language refuses to give it. Every definition teeters on a cliff. Every judgment is provisional, and every step towards certainty undermines itself. This paradox is a child of self-reference and vagueness. It is not about sand, really. It is about our words, our concepts, the fragile way we carve reality into categories. It is like Zeno's paradox of motion, where the infinite division of distance challenges the simple act of moving forward. Here, each grain, insignificant alone, accumulates into something undeniable, and yet the boundary is invisible. So what does this teach us? That truth is sometimes slippery, that clarity is a luxury of context, and that our systems of knowledge, legal, scientific, ethical, carry the same fragility. The Sorites Paradox whispers that our insistence on rigid definitions can blind us to the subtlety of reality. It reminds us that the world does not always bend neatly to our logic. And so you stand there, watching your small heap of sand, feeling the tension between certainty and ambiguity. You realize that the paradox is not meant to be solved. It is meant to be lived, felt, and questioned. The heap grows, or does it? And in that question, the universe quietly hums its disquieting answer. Some truths exist only in the spaces between our words. Omnipotence Paradox. You are standing in a vast empty hall. The walls stretch endlessly upward, disappearing into shadow. Your footsteps echo against stone floors, each one a reminder of the weight of the question before you. In your hands, you hold infinite power, or so you believe. Every possibility lies within your grasp. Every law, every rule, every reality can bend at your will. And yet, something gnaws at the edge of your mind. A question that refuses to be ignored. This is the Omnipotence Paradox, not just a puzzle, but a mirror held up to the concept of absolute power itself. It asks, can an all-powerful being create a stone so heavy that even it cannot lift it? A question that, on the surface, seems simple, but beneath it hides an abyss of logic and contradiction. Imagine the first scenario. You, possessing unlimited strength, shape a stone the size of mountains, denser than any matter known to the universe. It rests on the ground, unmoving, absolute. And yet, if you cannot lift it, your omnipotence seems incomplete. A crack appears in the idea of unlimited power. Now consider the second scenario. You choose instead to lift every stone imaginable, without exception. No stone can resist your might. But in that case, could you ever create the unliftable? If you cannot, your power is again limited. Every path leads to tension, a collision of absolute capabilities against the very concept of absolute freedom. Step by step, it becomes clear. The paradox is a form of self-reference. The statement about creating an unliftable stone refers back to the being who would create it. It's a trap of language and logic, where the definition of all-powerful becomes entangled with the constraints of reality and the structure of possibility. Much like the liar paradox, this statement is false. It loops back on itself, forcing us to question whether our words can ever truly capture infinity. But why does this matter? The Omnipotence Paradox isn't merely academic. It forces us to confront the tension between ideas and reality. Power, absolute or otherwise, must navigate limits, boundaries, and definitions. In human terms, it mirrors our struggles with ambition, control, and morality. Can we ever truly know the extent of what we can do? Can society, governments, or even our own minds achieve completeness without contradiction? In philosophy, it raises a deeper reflection. Is truth universal, or always entangled with perspective? Is omnipotence even coherent, or merely a symbol of human desire to define the infinite? And perhaps more unsettling, does the very act of questioning power reveal the inherent fragility of systems we believe to be absolute? So what's really going on here? The paradox is not meant to be solved. There is no correct answer that restores harmony to the concept of omnipotence. Its purpose is to provoke thought, to challenge assumptions, and to make the mind tremble at the edge of understanding. You stand in that hall again, the stone before you, infinite and immovable. Your power is total, yet the question remains. The paradox does not yield, it waits, and in that waiting, you feel something essential, the haunting awareness that some truths are not answers, but mirrors of the limits within us, and the universe itself. And as you leave the hall, you carry the question with you, a shadow lingering at the edge of thought. Omnipotence may be infinite, but the reflection of its paradox is something even the mighty cannot lift. Epicurean Paradox. You are standing in the shadow of a vast ancient temple. The wind whispers through empty corridors, carrying the faint scent of incense and dust. Your mind races, caught between awe and unease. Somewhere beyond the pillars, the world seems indifferent, vast, silent, and unknowable. At this moment, a question pierces the air. If there is a being of perfect goodness and infinite power, why does suffering persist? This is the stage of the Epicurean Paradox, a question that is not just a puzzle, but a trap for our understanding of the divine, morality, and the nature of existence itself. Consider the possibilities. If such a being exists, it must be able to prevent suffering, yet suffering continues. That leaves us with a contradiction. Either this being cannot stop the pain, or it does not wish to. But if it lacks the power, can it truly be called omnipotent? And if it lacks the will, can it truly be called benevolent? Each path twists logic back upon itself, leaving us suspended between belief and doubt. Imagine the first scenario. The being is all-powerful, but indifferent. Tragedy strikes, injustice unfolds, and the innocent suffer. Every act of cruelty in the world becomes a mirror, reflecting a divine detachment. Now imagine the second scenario. The being is all good, but limited in power. Here, mercy is real, but ultimately constrained. Your prayers, your hopes, your pleas, unable to bend reality in the ways you crave. In both visions, the promise of a perfect protector dissolves. The logic here is subtle, yet piercing. This is a paradox of divine attributes versus human experience. Epicurus framed it not to mock faith, but to reveal the tension between the ideals we assign to ultimate beings and the stark reality of suffering around us. It shares kinship with the problem of evil, the struggle to reconcile omnipotence, omnibenevolence, and the persistence of pain. The contradiction is not a trick, it is a lens, magnifying the dissonance between hope and evidence. Philosophically, it forces us to ask deeper questions. What does it mean to believe in goodness without control? What is the value of faith when outcomes are not guaranteed? This paradox touches the foundations of trust, morality, and understanding. It is not merely abstract, it shapes how societies justify suffering, how humans wrestle with justice, and how we confront the fragility of life itself. And yet, there is a quiet lesson hidden in the tension. The Epicurean Paradox is less about answering, more about observing. It reminds you that certainty is rare, that suffering is real, and that the search for meaning is unending. In the emptiness of the temple, in the wind through the pillars, the paradox whispers, perhaps the point is not to resolve the contradiction, but to recognize it, and in doing so, to confront the delicate, uncomfortable, and beautiful complexity of existence itself. So you leave the temple, the question still lingering in your mind. You walk into the sunlight, carrying a weight you cannot set down. The paradox remains unresolved, quietly demanding reflection. And in that quiet, you realize that some truths are not meant to be conquered. They are meant to be lived with, deeply, consciously, forever. Buttered Cat Paradox. You're standing in your kitchen late at night, the room dimly lit by a single flickering bulb. A cat slinks past your feet, tail swishing, purring softly. In your hand, you hold a slice of toast, buttered on one side, warm from the pan. You pause, half amused, half curious. What would happen if you tied this slice of buttered toast to the cat's back, butter side up? This is the Buttered Cat Paradox. On the surface, it sounds absurd, a joke told at dinner parties, but it's more than a whimsical thought. It's a collision of logic, physics, and expectation. It's a riddle that forces you to question cause, effect, and the very rules you think are fixed. Let's break it down. Cats, as you know, almost always land on their feet. It's a survival mechanism honed over millions of years. Buttered toast, on the other hand, has an almost mystical property in folklore. It always lands buttered side down. So now, you have two opposing forces. One determined by evolution, the other by gravity, or by bad luck, depending on who you ask. Scenario 1. The cat lands on its feet. The toast insists on hitting the floor butter side down. Which prevails? Your mind immediately hunts for an answer, for a rule that will dominate, but no rule seems to apply without contradiction. Scenario 2. The toast lands butter side down. But then the cat, obeying its feline instinct, twists mid-air, paws first, creating a miniature dance with physics that seems to defy reason. Perhaps the cat hovers a fraction of a second longer than gravity allows, caught in some cosmic stalemate, as if the universe itself pauses to watch. Each scenario loops back on itself. If the cat lands on its feet, the toast is upset. If the toast lands buttered side down, the cat is defying nature. You imagine the impossible. The cat, suspended mid-air, rotating slowly, neither feet nor butter touching the ground. A perpetual hovering paradox. This is a self-referential paradox, like the liar paradox, or the idea of a statement that contradicts itself. It's not about cats or toast, really. It's about rules that collide, and what happens when no outcome can satisfy all constraints. It's playful, yes, but underneath, it's a meditation on expectation, inevitability, and the chaos that erupts when two truths meet. Think of it this way. Life is full of buttered toast moments. Systems, societies, and even personal choices have built-in rules and habits that seem unshakable. And yet, when they intersect in unexpected ways, logic falters. You are forced to reconsider what must happen, and what simply could happen if certainty itself bends. The paradox teases a deeper truth. Sometimes, the world does not reward consistency. Sometimes, two forces you trust to always behave a certain way cancel each other out, leaving you with suspense, uncertainty, and a faint sense of awe at the sheer audacity of nature or chance. So what's really going on here? There is no solution, no trick, no experiment. No clever physics equation will resolve this tension completely. The point is reflection, not resolution. It's the reminder that some questions exist to make you pause, to make you wonder, to make you acknowledge that the universe sometimes refuses to play fair. And as you watch the cat meander across the kitchen floor, toast forgotten in your hand, you realize perhaps some contradictions are not problems to solve, but experiences to witness. And in that hovering, impossible space, the world seems just a little stranger and infinitely more fascinating than you ever imagined. Interesting number paradox. You are sitting alone, a piece of paper in front of you. The room is silent, yet in your mind, numbers begin to stir, whispering secrets you never knew they held. You decide to list all the positive integers, 1, 2, 3, 4, Each one a simple, solid thing, yet each one hiding something, waiting to be noticed. Your hand hovers over the pen because something strange is about to happen. This is where the paradox begins. Not with a theorem, not with a proof, but with a claim so simple it seems almost trivial. A statement so innocent that it lulls you into thinking numbers are merely numbers, yet they are not. It starts with a question. What is the smallest uninteresting number? Surely, every number has a property that makes it interesting. Some are famous, 7, a prime often called lucky. Some are perfect, 6, equal to the sum of its divisors. Others appear in stories, in science, in the rhythms of daily life. But if you decide to search for the first number that is truly uninteresting, a number with no remarkable features, your mind freezes. Because once you identify it, once you single it out as the smallest uninteresting number, it becomes interesting. So here's the paradox. You think, perhaps there is a number that is boring. Perhaps it has no defining features, no charm, no place in history. You write it down. The moment you do, its status changes. It is now notable. By definition, the act of naming it makes it exceptional, irreversibly so. The uninteresting number vanishes, replaced by a spotlight you cannot remove. Let's walk through this carefully. Imagine the sequence of natural numbers laid out before you. You search for one that stands out in no way. It seems unremarkable, but there is a twist. As soon as you recognize it as the first unremarkable number, it gains a property. It is the first unremarkable number. Congratulations, it is no longer unremarkable. The chain of logic collapses. There is no number left that is uninteresting. And yet, somehow, you know that numbers exist that appear ordinary at first glance. This is a self-referential paradox, born from the way we define interest. It resembles the liar paradox. A sentence that declares itself false becomes true merely by its declaration. Here, the number that declares itself uninteresting becomes interesting. It's not about mathematics in the traditional sense. It's about language, about observation, about how we assign meaning to symbols and structures. And now consider the philosophical weight. This paradox whispers about human cognition, how we cannot fully step outside the frameworks we create, how our attention itself creates value, how the act of observation changes the thing observed. The paradox is not just about numbers. It is about the impossibility of removing ourselves from the systems we inhabit. It challenges ideas of objectivity, of neutrality, of what it truly means for something to exist without notice. So what's really going on here? Perhaps it is a mirror, reflecting how our minds impose order, significance, and narrative onto reality. Perhaps it is a warning that in searching for the mundane, we inevitably encounter the remarkable. Or perhaps it simply reminds us, with a quiet grin, that some questions have no final answer. In the end, you put down the pen, feeling the weight of impossibility. The numbers sit there, indifferent to your contemplation, yet infinitely rich with hidden stories. You realize the point is not to resolve the paradox, but to recognize that even the simplest things are laced with contradiction, that curiosity itself transforms the world, and that the very act of noticing is an act of creation. And as you look at the list of integers stretching endlessly before you, you understand. Some mysteries are meant to remain unresolved. Dream argument. You wake up suddenly. The morning light streams through the window, brushing your skin with the warmth of reality, or so it seems. Your hands grasp the sheets, cold and tangible. Outside, birds sing, cars rumble, and life continues. Yet a shadow of doubt lingers in your mind. Could this waking world, be nothing more than a dream? This is the dream argument, a philosophical trap that has haunted thinkers for centuries. It isn't just a puzzle about sleep or illusion. It is a profound challenge to the certainty of what you believe you know. If your senses can deceive you while dreaming, how can you ever be sure they are telling the truth when you are awake? Consider the first scenario. You accept everything around you as real. You touch the coffee cup, feel its warmth, Hear the distant hum of the city. See the sunlight bouncing off the walls. But even as you do, remember the nights when your dreams felt just as vivid. Faces, voices, landscapes, all convincing. If dreams can mimic reality so perfectly, then the certainty of this waking moment becomes fragile, almost arbitrary. Now imagine the second scenario. You treat your waking life as potentially illusory. Every sight, sound, and touch becomes suspect. The cup might not exist. The birds might not chirp. The sunlight might be a trick. Logic itself feels slippery, because if everything could be a dream, how do you act? How do you choose? How do you trust your reasoning? Each step forward is a hesitant negotiation with an unseen architect of illusions. The logic of the dream argument rests on skeptical self-reflection. It's a question of epistemology, the study of knowledge. It is similar to the liar paradox in that it loops back on itself. If you cannot distinguish dream from reality, then claiming to know anything about the world becomes suspect. Like a mirror reflecting a mirror, your certainty reflects uncertainty, ad infinitum. But the philosophical weight goes deeper. This paradox forces you to confront the fragility of trust, both in your senses and in your mind. How do you navigate a world that might be unreal? What does it mean to act ethically, to pursue goals, or to love someone, if the foundation of reality is uncertain? And yet, despite the doubt, life insists on continuing. You are compelled to make choices, to move, to breathe, even while suspicion lingers. So what's the insight here? The dream argument does not demand resolution. It is not a problem to be solved with clever reasoning or scientific certainty. Its point is reflection. It asks you to feel the tension between what seems real and what could be imagined. It teaches caution, humility, and awareness of the fragile line between perception and illusion. And as you sip your coffee, listening to the city hum, perhaps a shiver runs through your spine. What if waking life is only another dream, slightly brighter, slightly more persistent than the one that vanished the moment you opened your eyes? Unexpected hanging paradox. You're sitting alone in a dimly lit cell. The air is cold, heavy, and unyielding. Your hands are clasped together, and your mind races with every possible thought. Outside, the world moves on. Oblivious to the tension inside these walls, a guard approaches and delivers the sentence. You will be hanged at noon on one weekday next week, but the day of your execution will be a surprise. You will not know the day until it comes. The words echo in your head. You try to grasp the meaning, to predict, to control, but the very premise feels like a trap, an intricate puzzle woven with logic, certainty, and the unknown. This is the unexpected hanging paradox, a paradox that challenges the very essence of knowledge, expectation, and surprise. You begin to reason. If you imagine the week, day by day, starting from Friday, you think, if I am still alive on Thursday night, the hanging must be tomorrow. But then it wouldn't be a surprise. So you conclude you cannot be hanged on Friday, and then Thursday. If Friday is impossible, Thursday becomes the last possible day. Yet, if you realize this in advance, then Thursday would also not be a surprise. Step by step, day by day, your logic appears airtight. The execution cannot happen at all. But then the week unfolds. You go to sleep, thinking you are safe. The next morning, Wednesday say, the guard enters. Your heart pounds. You are hanged. Shock seizes you. You did not expect it. The paradox has worked. Reality defies your own reasoning. This is a self-referential paradox. It collapses when you try to predict the unpredictable. The logic loops upon itself. Your knowledge about the surprise changes the conditions, yet the condition itself relies on your ignorance. It's not just a clever trick. It is a reflection on how expectation shapes reality. It is similar, in a strange way, to the liar paradox, where a statement refers to its own truthfulness. This statement is false, or Schrödinger's cat, caught between life and death, depending on observation. Here, your prediction interferes with the outcome, creating a tension between certainty and surprise, Philosophically, it asks, can knowledge ever be absolute if it changes the future it seeks to predict? How do we measure trust and control when anticipation itself alters reality? It's a mirror to systems, legal, social, psychological, where human reasoning meets uncertainty. And yet, it is personal, intimate, a paradox playing with your own sense of expectation and fear. So what's really going on here? Perhaps the point is not to escape the trap, not to outwit it. Perhaps the point is to feel the fragile edge between reason and uncertainty, to confront the limits of logic, and to witness how even the most airtight predictions can collapse when confronted with the unexpected. You sit in that cell, heart pounding, mind spinning, knowing the paradox has already begun to unfold. You realize that sometimes the greatest surprises come precisely because we try to anticipate them. And in this quiet tension, you are left with a singular, unsettling thought. Even certainty can be deceiving. The week stretches on. You wonder, will it happen again? Or has the paradox already passed through you, leaving only its echo, a whisper of uncertainty that logic alone cannot contain? Ross-Littlewood Paradox. You are standing in a vast empty hall, the kind of place where echoes linger long after the sound has died. In your hand, a seemingly ordinary urn, polished black and hollow, feels heavier than it should. You can hear a distant clock ticking, each second stretching impossibly long, each tick demanding a choice you cannot quite make. The room seems infinite, yet the urn is small, almost intimate. At this moment, your mind races with a question that shouldn't matter, and yet it does. This is the Ross-Littlewood Paradox. At first glance, it appears simple, a thought experiment about balls, an urn, and the passage of time. But it is not just a puzzle. It is a trap for logic itself, a place where intuition stumbles and certainty evaporates. Imagine this. At the start of the first minute, you place 1,000 balls into the urn, numbered from 1 to 1,000. At the halfway mark, 500 balls are removed, the largest numbers vanishing into the void. In the next half minute, you add another 1,000 and remove 750. Every subsequent moment follows this pattern, endlessly compressing into the next fraction of time. The process accelerates, folding into itself, moving toward the first hour, where all these infinite steps will be complete. So what remains in the urn at the end? Your instincts rebel. Surely it is filled with countless balls, some fragment of the endless additions. Yet the logic twists. Every ball you thought might remain has been scheduled for removal, some earlier, some later. Each possibility leads to contradiction. You expect fullness, yet calculation predicts emptiness. You try to hold the concept in your mind, and it slips like water through fingers, simultaneously there, and yet gone. Here, the paradox is not just in the numbers. It is a paradox of infinity and limits, of adding and removing without ever reaching an intuitive conclusion. It whispers to you like Zeno's paradoxes, where motion itself becomes suspect, and to the Grand Hotel of Hilbert, where infinity defies the ordinary rules of counting. It confronts you with the unsettling idea that the infinite is not merely large. It is alien to your reasoning, bending your sense of cause and effect. And now, consider what this means beyond numbers and balls. It is a reflection on processes, on systems that seem predictable, yet hide subtle contradictions, on planning, on accumulation, on erasure, on life itself, where actions and consequences intertwine in ways that defy our intuition. How do we know what truly remains in the world when every addition comes paired with subtraction, every growth shadowed by loss? The paradox becomes more than math. It is a meditation on trust, on certainty, on what we believe exists versus what actually does. So when the final minute passes and the hands of the clock rest in silence, you are left holding the urn. Empty? Full? The question is no longer about balls, but about your understanding of infinity. and the fragile scaffolding of logic upon which you stand. Perhaps some truths are meant to be felt rather than resolved. Shadows on the wall of reason that remind you, not everything can be contained, not everything can be known, and some mysteries exist simply to make you question the world you think you understand. The urn sits quietly. You breathe, and in that silence, you realize that the paradox was never about the balls at all. It was about the mind that tried to hold them. Catch-22. You are sitting in a sun-bleached tent on an airfield somewhere in the Mediterranean. The dust clings to your uniform. The heat presses down on your chest, and the distant roar of planes keeps your mind on edge. Your squadron commander walks past, clipboard in hand, eyes flicking over the names of men he barely knows. You want out. You want to escape the madness. But at this moment, the rules themselves seem alive, twisting, suffocating, impossible to outrun. This is Catch-22, not just a quip or a bureaucratic joke, but a trap woven into the very logic of survival. It is a paradox that doesn't hide behind symbols or riddles. It lives in policy, in orders, in the thin line between sanity and duty. And you realize, with a sinking heart, that understanding it is not enough. It demands you feel it, live it. You might try to plead that you are sane enough to fly no more missions. You are afraid. You recognize the danger. Surely reason would protect you from harm. But the rule intervenes. If you are rational enough to want safety, you are deemed sane, and a sane man is fit to fly. To opt out is to prove you are fit to continue. Your logic folds back on itself, like a hall of mirrors where every exit is blocked by reflection. Or perhaps you attempt the opposite. You declare yourself insane, hoping the absurdity of your plea will spare you from further combat. But here too, the paradox tightens. Only a man who is truly insane would voluntarily continue dangerous missions. If you refuse them, if you protest, it proves you are sane. And so, whether you act out of fear, reason, or desperation, the system spins you back into its grasp. There is no escape. Every route loops into itself. Every choice traps you. Catch-22 is a self-referential paradox, born not from numbers or time travel, but from the cruel circularity of authority and definition. It mirrors other logical loops, like the liar paradox, where statements refer back to themselves, contradicting their own premise. But here, the stakes are flesh and blood, courage and exhaustion, survival and death. It is a paradox you don't solve on paper, you feel it in your marrow. Philosophically, it asks a question we seldom face outside military bureaucracy. How do we navigate rules that define their own exceptions? Systems that claim fairness while trapping those who obey? It is a meditation on power, on trust, on human reason rendered impotent by its own rigor. The absurdity mirrors life itself, job markets, legal loopholes, even the contracts we sign without reading. Logic alone cannot free you. The machinery of definition always finds you wanting. And yet, perhaps the deeper weight is not in the rules, but in your own awareness. Knowing the trap does not change the trap. Every choice you make carries the shadow of inevitability. Catch-22 teaches that understanding, by itself, is no shield. That reason, when enclosed by its own structure, can be the most relentless prison of all. So what do? You follow orders, you fly the mission, you laugh at the absurdity, you write letters, hope, protest. And somewhere inside, a small part of you recognizes that the point is not escape, not solution, but reflection. The world is often a catch-22, where logic bends, fairness falters, and survival is no simple calculation. And as you watch another plane lift off into the burning horizon, you feel it. The quiet, unsettling truth that some paradoxes are meant not to be solved, but to remind us of the limits of reason and the fragile weight of freedom. Inspection Paradox. You wake up before dawn. The streets are quiet, the air thick with the kind of stillness that makes every sound sharper, every movement more pronounced. Somewhere in the city, a bus passes, its headlights cutting through the fog. You check your watch, your mind races. How often do you really notice the world around you? And how often does it notice you? This is the moment where the inspection paradox comes alive, a subtle trap hidden in the patterns of chance and observation. It's more than a statistical curiosity. It's a lens that shows how the act of looking, of measuring, twists the reality you think you understand. Imagine a bus stop. Buses arrive at irregular intervals. You, as a random passenger, step out to wait. You assume your wait is average. You assume the intervals are fair. But in this scenario, that intuition betrays you, because the longer intervals are more likely to be observed. The buses you notice, they're not typical. Your perception is biased. Your experience stretches time itself. Two possibilities emerge. In the first, the buses are scheduled evenly. You wait, and the world feels predictable. Your mind settles, reassured by the rhythm. But this is a mirage. In the second, the buses are irregular. Some come close together, others leave long gaps. The longer gaps dominate your experience. Every time you check, you find yourself in a lull, feeling abandoned by the schedule. The paradox sneaks in. The longer intervals are more visible precisely because they are longer. Your observation is skewed. Reality hides its uniformity behind the veil of your perspective. Step back and consider the logic. The inspection paradox belongs to a class of statistical and self-referential paradoxes. It's related to what mathematicians call length-biased sampling. When you randomly select a moment to observe a system, your observation is not uniform. It favors extremes. In some ways, it's like standing by the highway and thinking every car is a sports car, simply because the slow trucks take longer to pass, giving you more time to notice them. But the philosophical weight is heavier. The paradox whispers that truth is rarely what it seems. Observation is not passive. Measurement is not neutral. The world doesn't yield itself evenly. It shapes itself to the gaze. In life, as in statistics, our intuition is seduced by the most conspicuous, the most lingering, the most dramatic. We trust what we see, but what we see is a skewed fragment, a biased reflection of the whole. So what's really going on here? It's not about solving the paradox. It's about realizing that our experience, our perception, is a lens that magnifies certain truths while hiding others. Every moment of waiting, every pause, every unnoticed bus, these remind us that observation is entangled with reality, that chance and choice are inseparable, and that the world is never as simple as it seems. And as the fog begins to lift, and the distant hum of engines rises, you understand. Sometimes, the most revealing truths are not in the events themselves, but in how they are seen. Birthday paradox. You are at a crowded party. The room hums with chatter, laughter bouncing off the walls. People clink glasses. You glance around and notice the sheer number of faces, each unique, each with their own story. Your mind starts to wander. How likely is it, you wonder, that someone here shares a birthday with someone else? Just one day in 365. Yet somehow, the thought makes your chest tighten with curiosity. At this moment, probability feels like a living, breathing creature, whispering secrets you can't yet grasp. This is the stage for what mathematicians call the birthday paradox. It's not a paradox in the sense that it breaks math. It doesn't. But it breaks your intuition. It challenges what you feel should be true and forces you to confront the hidden patterns in randomness. Imagine a smaller room first, 10 people. You'd expect the odds of 2 sharing a birthday to be low, almost negligible. But here's where the paradox twists. Every new person you consider doesn't just have to match your birthday. They can match anyone else's. Suddenly, the possibilities explode. With 23 people, just 23, there's already a better than 50% chance that 2 birthdays collide. You would never guess it. Your instincts, shaped by everyday life, tell you the odds should be rare. And yet, probability whispers otherwise. Let's walk through it step by step. You are the first person in the room. No conflict yet. A second person arrives. The chance they don't share your birthday is 364 out of 365. Pretty high. A third person steps in. They must avoid both of the first two birthdays. 363 out of 365. And this continues. Multiply these probabilities together, and the numbers shrink faster than you imagine. By the time the 23rd person enters, the likelihood that no two people share a birthday falls below half. Logic and intuition diverge. Your mind protests, but the math is relentless, so this is a classic case of a probabilistic paradox, where human intuition about rarity and randomness clashes with combinatorial reality. It's similar in spirit to the Monty Hall problem, where your gut says one thing, but structured reasoning proves another. The birthday paradox doesn't lie. It forces honesty in the way we perceive probability. It exposes the quiet, counterintuitive rules that govern chance. But beyond numbers, it carries deeper weight. It's a reminder of hidden connections, unseen patterns that link people together in ways you wouldn't expect. Trust, coincidence, and coincidence mistaken for destiny. They all mingle in the same space where probability quietly governs. In life, as in this room, surprises are more likely than you believe. Systems, networks, relationships, they all harbour their own birthday paradoxes. You walk through the world assuming independence, yet overlap is inevitable. So what's really happening here? The paradox isn't about birthdays. It's about perception, about how your brain measures likelihood against reality. It's about humility, about acknowledging that the universe often defies your intuition. In this way, the birthday paradox becomes a meditation on coincidence, on connection, on the quiet mathematics of being among others. And as the party swirls around you, laughter echoing, you notice a pair of faces, strangers until this moment, smiling at each other, born on the same day, a collision of probability you never saw coming. It leaves you with a thought that lingers long after the music fades. The world is stranger, more interconnected, and infinitely more surprising than your instincts would ever allow. Hedgehog's Dilemma. You are sitting alone in the quiet of a winter morning. The frost bites at your fingertips, and the soft crunch of snow under your boots echoes in the emptiness around you. You see another figure in the distance, moving closer, cautious, yet curious. Your heart quickens. There is warmth in connection, yet fear. A subtle sting holds you back. Every step forward feels like a gamble. Every step backward, a surrender to isolation. At this moment, the very act of approaching feels like threading a needle through a storm. This is the hedgehog's dilemma. It is not just a metaphor. It is a puzzle of intimacy, of trust, of the painful tension between the desire to connect and the risk of hurting or being hurt. Imagine hedgehogs on a cold morning, huddling for warmth. They inch closer, seeking comfort. But the closer they get, the sharper their spines prick. And soon, the warmth they seek is matched by the pain they cannot avoid. Move too far apart, and the cold is unbearable. Move too close, and the sting overwhelms. There is no perfect distance, only negotiation, only compromise, only tension. So what happens when you make a choice? You reach out, you move closer, hoping to share warmth, to form a bond. But the moment of contact, inevitable discomfort. Emotional prickles pierce, doubts flare, small betrayals, or your own fear, wound you. Step back, distance yourself, preserve your comfort. The pain is less, but now isolation gnaws, the cold of loneliness pressing in, and no matter what choice you make, some form of suffering persists. The paradox lies not in numbers or logic, but in human and hedgehog experience itself. It is a psychological and relational paradox, a mirror reflecting the contradictions of intimacy. Like the prisoner's dilemma in trust, it shows that even with the best intentions, connection is fraught with unavoidable consequences. Unlike a mathematical puzzle, there is no solution here, only navigation, only constant recalibration of closeness and distance, desire and fear. But now pause and reflect. This is a lens on more than hedgehogs. It is the architecture of human relationships, the foundation of society, the dance of trust. Every friend you make, every love you hold, every conversation you dare to open carries echoes of this dilemma. The closer you get, the more vulnerable you become. Every act of trust carries risk. Every retreat carries loss. Logic and warmth clash, and yet, paradoxically, it is only through the sting connection feels alive. You realize, perhaps with a chill that runs deeper than winter air, that the hedgehog's dilemma is not meant to be solved. Its purpose is reflection, to understand that human connection is a dance of courage and caution, warmth and pain, and sometimes, in the quiet between the steps, you see that the choice is never final, the distance is never perfect, the warmth is never complete. So you stand, shivering slightly, considering the other hedgehog in the snow. You wonder, do you move closer, risking the sting again, or step back and face the cold alone? The answer, you know, will not be found in logic, but in the quiet courage of trying anyway. And in that pause, the paradox lives,